There are a lot of ways to start out building guitars, and what a lot of people will choose to do is to build a guitar that they know and love. However, I'll be showing you information on how to design your own guitar style and build that if you do so choose. Now, just a little couple things about the design here. This is what I call my Marlin shape. It is 14 inches across and 18 inches long, and that seems to work for me. That's a little large, especially across compared to most production guitars, but I like a bigger guitar. But the general consensus seems to be somewhere around 12 3/4, 13 inches if you're looking at production guitars that are currently on the market for electrics. Now, one important thing to notice when you're doing this is I've marked off where the bridge is going to be on my guitar, just to make sure that I like where that sits. And I simply did that by finding out this is where my 15th fret connects, and I measured the distance from the 15th fret here and just placed my bridge to make sure it looks good. Now, when drawing out your guitar, there's a couple things to keep in mind. You want these curves to be as smooth as possible so that they are visually appealing. Some people have an eye for it, and you can simply freehand them and then perfect them by just erasing and redrawing them until you get them perfect. Another way to do it is with a tool called a French curve. I don't actually have one. A lot of people find them handy. It's just a you'll see a French curve scraper later in the video, but there's also a French curve designing tool, which is essentially just a designing aid that has curves on it that get gradually tighter, but they are all visually appealing curves, so you can use them, and such as to make these curves look visually appealing with ease. Another thing to keep in mind is if you want your shape to be symmetrical about the center of the guitar, then I'd suggest drawing one half and then flipping that over and tracing it onto the other half. As you can see, mine is symmetrical until you get to about the waist, and then obviously the upper bout and the lower bout are quite different. But what I did is I drew the upper bout first till about here, cut out that piece, flipped it over, and just traced it on both sides here. One last thing about designing, you may want to mark out roughly where your neck is going to be, just to see if you like the access that your cutaway gives, and that the neck covers any areas like this horn. I want to be under my neck area because I'm going to carve that out. Also, now's a good time if you're going to do an extra large belly cut, or like I'm doing here, a cutaway to gain upper fret access. Now would be a good time to mark out any chambering that you plan on doing on the guitar. I'm not planning any on this one, but if I were to, I would watch out for areas such as where the bridge goes, perhaps my pickups, obviously where the neck is, and any carve. I don't want to carve into my hollowing cavities. And also, just generally, try and keep about, if you have large cavities, keep about a ½ inch distance. So if your cavity is like that, you want to keep about a ½ inch, especially on places where there's lots of ingrain. To make your template, we're going to go to the copy store and make a copy of your design blueprint so we can cut out the shape of the guitar on the copy and trace it onto 1/8 inch hardboard. Now, there's a couple reasons why I use 1/8 inch hardboard for my master templates. We're going to be making 1/2 to 3/4 inch thick MDF templates to use in the actual routing process, but I make all my master templates out of 1/8 inch hardboard for two reasons. One, since it's not as thick as the MDF material, you can make a more accurate template with perfectly perpendicular sides, etc., etc., with a lot less effort than if you were to do it with thicker MDF material. It's a lot easier this way. And secondly, when we use this master template to make a thicker MDF copy, we will always have this master template because MDF, well, and hardboard, but they both deteriorate over time with use of bearings, etc., etc. And so the fewer copies you have to make off your master, the better. So I keep a 1/8" hardboard master of all my templates, and then when the MDFs start to get a little questionable, I then make a copy so that the master isn't what I'm using every single time, and I've always got it safe. Next, we're going to take this outline onto your saw and cut it out pretty close to the line. As you can see, I've left a little room outside my template line to work with, and this will help when we are shaping it to perfection on the oscillating spindle sander and the disc sander. I want some room to work with. We're going to start by doing all the convex surfaces on our disc sander, just by going up to our line, keeping everything perfect. One good way to see if you're got any lumps or irregularities is to use what I call silhouette light. Just hold the template up to a light source and you'll be able to better see any irregularities along your edge. And then after we do that, we'll go in and get our concave surfaces on the spindle sander. And yeah, just go ahead and bring it up to the line. Now we're going to go ahead and do the concave areas with this spindle sander. One little trick is use the largest diameter spindle that you can for the curves that you're doing. It'll leave a smoother transition and you'll have to do less work. Another trick is hit all your visible high points and then do sweeping passes, and those will take off evenly. If you don't hit your high points off first, then it'll just continue putting those bumps into it. Another little trick is I keep a small piece of sandpaper around, because when you're sanding it flips up the little edges and it makes it hard to see your profile. So I just knock off those edges before I hold it up to the light to see. And here's what your template should look like when it's finished. Graceful, sweeping, elegantly transitioned curves. Let's talk a little bit about wood selection. There's many things that need to be taken into account when building a guitar, and a lot of it has to do with grain orientation, but as well as aesthetics. For the top of a guitar, especially on an electric solid body, the grain direction doesn't really matter too much. Obviously you want the grain going like so. You can't have the grain going across, or else the expansion will change your intonation, and that's just a weak way of orienting the grain for a guitar. However, as long as the grain is heading in this direction, it can be quarter sawn, flat sawn, riff sawn. It's not a huge deal for an electric guitar top. Not so for an acoustic top, but that's not what this video is about. Here you can see some Clara walnut that's book matched. It's been sawn down the center and glued up so that it's a mirror image on both sides. And this is pretty much the norm for guitars, is to have a book matched top, be it walnut or flame maple or just something that looks good. Here we have some electric guitar back wood pieces. And there's a couple things to keep in mind. Once again, the grain is orientated top to bottom. You can't have it coming across like this. But there's a couple things to keep in mind when doing your bodies. Grain orientation as far as quarter sawn, riff sawn, flat sawn, it's not really important. But it's nice to get pieces that match up. Like in this guitar's case, these are both flat sawn, as you can see. So each half goes together quite nicely. Also, if you look here, I've oriented it so that across this glue line here, it goes flat to flat, so that things almost match up and they'll look nicely. Here's another blank where they were riff sawn, and so what I've done is I've oriented it so that they continue across in the same direction. Another option that looks nice is if the pieces have the same exact pattern of rift. you can actually make them opposite, and so they V out from the glue line instead of continuing across it. Both of them are accepted and work perfectly fine. Now next are where you've got to pay the most attention to your grain orientation. As you can see here, this neck is perfectly quarter sawn, and that is the best option that you can get. The other next best option is perfectly flat sawn. The reason for this is wood expands when it finds changes in moisture, and on a quarter sawn piece it will simply expand out like this, and since it is so even, it's an even expansion. Whereas in a flat sawn piece, a slight change, a slight arc in the grain, well, that means it's perfectly flat sawn in one spot and a little not quite so flat sawn in another. So it won't change exactly the same in the two spots of the flat sawn grain. But I mean, a little bit of an arc is not an issue. Where you start getting the issues is in rift sawn grain, like we saw on this body. Imagine if this was a neck and it found changes in moisture. I mean, it's not necessarily going to expand strangely, but you run a higher risk of the wood expanding and warping in a way that your truss rod can't battle. A truss rod can only battle back and forward, but if the neck twists to the side, then there's nothing you can do about it. That's a done neck. So keep that in mind when choosing your neck wood. The only way you can really use rift sawn wood, in my opinion, is let's say this was perfectly rift sawn. You could rip this down the center, flip everything, and then glue it back so that you had a V pattern. And this essentially cancels out the sideward motion, and you're left with something that only warps in up or down, which the truss rod can handle. For gluing up guitar blanks, first I thickness the board to what I want. In this case, I did it to 1.5 inches, and that's good for either adding a 1/4 inch flat top if you're doing a flat top guitar, or for adding a carved top and leaving the edge at a 1/4 inch. Pretty much the general consensus is that 1 3/4 inches at the side is a pretty good size. And you can do this a number of ways with a planer, a sander, or one of my favorite ways is I just set my bandsaw up to 1 3/4 of an inch, or sorry, in this case 1.5 inches, and simply resaw off what I don't need, and then I can keep that extra resaw in piece for other projects. But what we need next is a nice edge to glue up. So what we're going to do is just send it through our joiner, and that will give us a great edge. And just do it until you get a nice flat, clean edge, and test it by bumping it up against your other piece. To glue up your body blank now, just smear glue all across one of the edges that you're going to be joining. And then what we're going to do is we're going to put these down next to each other, and I'm just going to move them together to smear the glue on the other side. Now we're going to put the clamps on. Alright, now we've got the clamps on here, and as you can see I've done a number of different things with them. What I'll start out by doing is I will take a clamp and clamp it over the center line on each end, and what this is going to do is it's going to keep the two pieces of my board even and flat across the surface. Then I will go ahead and add clamps that clamp the piece together. And one thing to keep in mind is don't over tighten the end clamps until you have these side clamps on. You don't want to kind of clamp things how you don't want them. And one thing to keep in mind when you're doing the side clamps is the way that physics works is the pressure is going to extend at a 45-degree angle from the points where the clamps are touching. So be sure to get enough clamps to distribute pressure evenly across the whole blank. Also, don't worry about the glue squeeze out, and I really don't bother planing or sanding the pieces before glue up, because after everything is dry I'll just take a scraper And I'm just going to go ahead and scrape off all the glue, and then I'm going to have to send it through my sander anyways, or planer anyways, to true everything up, so that'll help get rid of that. Here's another fun glue-up method for pieces of wood that are really too thin to put clamps on. They would just crack under the pressure of a clamp. What you can do is joint them just like normal, and then you can stretch the tape. I usually do it by sticking it to one side and then pulling it across while holding the piece and detaching it. And I just alternate them, one pressure this way, one pressure that way, and I do it on both sides. And that's a great way to glue up thin pieces of wood. This is good for anything a 1/4 inch, or not even a 1/4 inch, let's say 3/16 and less. A 1/4 inch would probably be pushing it a little bit. You can use clamps on the 1/4 inch piece. But if you're doing a carved top, obviously this isn't the way to do it. Use clamps. This is just for back pieces, accent veneers, etc. Alright, now here we have our wood out of the clamps. As you can see, we've got glue along the center line, and it's still rough. All I'm going to do is take either a scraper or just an old plane, one that's not great anymore. Make it your designated glue plane or glue scraper, and just go over it and get off all these little nubs, because these are these are a little much for your sander to deal with. Stuff like glue tends to gum up sanders pretty quick, and obviously if you're trying to get things flat, if you've got these on both sides and you send it through your sander or planer or whatever you're doing to get a nice finished surface on this, this is going to raise up the bottom and make it so that it tilts. So we need to get rid of these before we do anything else. And here we're just going to give the body a quick send through our sander until all the glue marks are gone. The method of carve that we're going to be using is the method that I call a topographical carve. As you can see, I've left some extra space along the edge. I've drawn where my template says the guitar shape will be, and I've left about 1/2 inch on either side of the line. That's going to be the edge of our carve. Now, one important thing that you're going to need to do is you're going to need to get your fretboard out, and you're going to have to figure out where your bridge is. Your bridge is, at least in the type of carve that I'm doing, the bridge is going to be at the high point of my carve. So I'll do that, and then we'll get back to it. As you can see, I've now decided that I'm going to connect my 25.4 inch fretboard a la Martin Acoustics at the 19th fret is where it's going to touch, which puts my bridge right about there. Now my carve will then be centered around that position, and I'm going to go ahead and draw out the topography. Now what all that is going to be is, just like you've seen any map, it's going to have your highest part with a circle, and the next lowest a circle, and it will follow the shape of the carve, and then we're actually going to go to another tool and start cutting that out. But what I first do is I'm going to do a 5/8 inch carve. So what I'm going to do is I'm going to put a topography line for every 1/8 of an inch that I'm going down. So then I'm going to go back, because I don't really want to cut an 1/8 of an inch at a time on a safety planer. I'm going to go back and draw 1/16 inch lines in between that. And this is going to give me a nice looking carve. As you can see, I've now drawn out the topography for the for every 1/8 of an inch. You can see that it's going to start high here and bell out. These are closer together here, so that means it's going to be a steeper carve, and it gets shallower as it gets to the edges. So you're going to get a nice curve down and then bell. And I've done the same thing for everywhere. Now I'm going to go back and I'm going to put in 1/16 of an inch topography. In the end, I actually opted not to do 1/16 inch graduations. I kept with the 1/8 inch ones. That doesn't mean that I'll be cutting an 1/8 of an inch at a time. I'm still going to go in 1/16 of an inch increments when I'm doing the cutting. But the 1/8 of an inch gives me more freedom to hand carve a little later, which we'll see. And because this is a new shape, I decided that I want that freedom instead of a more finite and structured carve. Just it lets me perfect it a little more. Once I know exactly what the carve is going to be like and I do another of this style of instrument, I'll go to 1/16 inch graduations. What I've done here is one of the major problems with this typography carve style is that each time you do a pass for a 1/16 of an inch, you lose the lines. So even though I have them drawn out here, the first time I do a pass, which is going to be everything except this center circle, I'm going to lose every single one of my lines. Now the outside line's easy because everywhere it's a 1/2 inch, but the other lines aren't, and I don't want to have to rethink my carve every time. So what I've done is I've just taken some tracing paper and I have copied out the carve pattern onto the tracing paper. That way, every time I have to redraw the carve structure on, I just take something sharp, not as sharp, something hard, and that way I can just push down really hard and follow the carve of that hard object. And what that's going to do is it's going to put an indentation in the wood, so that when I can pull this away, I can redraw my lines. And now we're about to head over to the drill press to start getting cutting. This is the tool that we'll be using to carve out the typography. As you can see, when I rotate it, it's got 3 cutters that spin around, and it essentially works as a kind of like a planing router that is chucked into your drill press. And over on the side here, I've got my depth stops. So what I'll do is I'll set it to the initial depth with the table, and then subsequently each depth that I need to go from there, I will move these up a 1/16 of an inch, so half of one of these lines, and go from there. And that's going to let me accurately do my carve without changing the setup every time. One more thing to keep in mind when you're doing this is that the cutter heads are spinning this direction, clockwise if you're looking down the spindle. So you have to keep in mind that when you reach somewhere like this, if it's unprotected, it'll chip that out. So remember to come in at these parts straight and do them very slowly. One other thing that I'm going to do is, for this first pass, I'm going to check my depth to make sure that I've got it routing at the correct 1/16 of an inch. I'll do it outside the pattern where it doesn't matter, because I mean that's going to go down a huge amount later. Also, this is essentially a router, and routers run at much higher RPMs than a drill press. So you're going to have to run this at the highest speed that your drill press can take, and that coupled with the wider diameter of this will make up for the velocity that a router has versus tangential velocity that a router has versus this, and it'll make it cut well. And there's my test cut. Now that we've got our depth set, I'm going to go ahead and do part of a pass with you watching, and then it's a pretty simple process, and you get the idea, and we'll show the end result and also the transferring of the topography lines as we go, so you can get an idea of what we're doing. There's no reason to watch 20 minutes of safety planning. And that's the start of that first pass. I'm going to bring it all the way in until this first line. Alright, and here we are back at the workbench. We're now done with the first pass with the safety planer, and this is essentially what it looks like. As you can tell, it doesn't have to be exacting. It just has, it's going to guide your carve later. So that's our first pass. That's now at 1/8 of an inch. And we can check that with our rule. Perfect. Now what we're going to do from here is I'm going to show you putting these lines back on, and then you've obviously seen what the safety planer does, so I'm going to go back and do the rest of this, and we'll come back when I've got all my topography cut out. Oh, I also forgot to mention that it's a good idea to put a center line and some markings on your traces that allow you to find back where you were. And I know that all my edges are exactly 1/2 inch from the side, and I know where my center line is. So there we go. I now have back where I was. I'm just going to use a pen with its hard point to put pressure on these lines so that when I take this off, I now have them. Just go back over them in pencil. Actually, that time I pushed so hard it actually drew through the vellum, which is good. So now I've already got my lines. Actually, there's a couple spots that it missed, but other than that, I'm now ready to go for round 2. Alright, as you can see, we've now finished the topography cuts, and you can kind of get an idea of what the carve is going to be like. And a couple things I forgot to mention. The outside, that 1/2 inch ledge, that's my 0. So as you can see here, it goes maximum of 5/8, 4/8, 3/8, 2/8, 1/8. The 0 is actually outside of what will eventually be the guitar, because that's the line on the guitar. That gives you a 0 to carve to, because this is the corner where 1/8 meets 2/8 is the only part that will remain 1/8. So you have to carve into the 0 for the edge. The other thing I forgot to mention is always feed the wood against the rotation of the cutter. If you feed with it, it'll grab it, just like any sort of router. One thing that I like to do when I'm doing my carve, now that I have the topography done, is have a course of action when you're planning your carve. One of the things that I do is I'll come around with my plane, and I will smooth all these edges. And I mean, it's just something that helps me visualize the carve better. And then I will actually do from the center down to where the neck will be to make that curve, and then the back, and then I will graduate out. And it's always just good to have a course of action when you start. Let's just talk a little bit about the planes that I'm using. I use 2 different size Ibex round bottom planes. As you can see, they're not a flat bottom. They can tilt like this. And this is sold as the cello maker's plane. And then I also have one of the violin maker's planes. They're both Ibexes. And let's see if we can't get a measurement on these. Let me grab my ruler. The cello plane is just at 3.5 inches long, and the little one is 1 3/4 inches long. And these are the 2 planes I use. I really haven't found a need for any other planes. So yeah, let me set up some stuff and we'll get to carving. That noise you hear in the background is, I'll turn it off. I've got a little foot switch down below that lets me change, well, sorry, not change it, turn it on and off. But this is actually a vacuum system that keeps things held. So all I have to do is I keep that plate held with something to keep it from popping up and something else to keep it sturdy with my little bench dogs here. and then you just put it down on it, turn it on, and it's not going anywhere. And it makes it so that I have both hands to do my carving. I'm just going to show you quick what I mean by rounding the edges. I'm not going to show you the whole thing because obviously it's boring to watch something that long. But we'll show you how I'm doing it, and then we'll come back when they're all rounded and we start actually getting some nice carving done. And you always want to go with the grain, so you want to go downhill. If I were to try and go uphill, it would just pull. Here's a good example about what I mean. As you can see, it's still steps, step, 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 and I've just started hitting this area. And see how I've just blended it all until these ridges start to disappear where the cuts were. Now I'm going to do that all around the entire instrument. I mean, up till now, I've been using the cello maker's plane exclusively. It's only when you get into these tight areas that the smaller plane will come into effect, and also it helps out a good deal when you're doing like the final carve, because it's not taking out huge chunks like this one, and you can do things like cross hatching to get rid of high spots, but we'll deal with that later. As you can see, at this point, you're not really trying to be graceful or calculating or anything like that. Literally right now, it's just about stock removal. And as you can see, it really is a good idea to become ambidextrous with a carving plane. I mean, I'm not perfect yet. Every now and then, when I'm getting into a tough spot, I'll switch around so that I can use my left hand. But I mean, it's really helpful to be able to just switch back and forth. And as you can see here, it's actually okay to go cross grain. That actually helps out a lot in some spots. And here I'm just kind of carving out that little plateau at the top. See, so now you're getting a little bit of an idea as to what this carve will look like. It's hard to show it here. But, yeah, see, nice little bell carve. And it's already looking like a carve, even though all we've done is hit these ridges. We haven't even started perfecting the carve, and it's already looking like a bell. If that's the case, then you know you did your topography right. See, I'm starting to get into some of these tighter areas where, because of the length of the plane, as you can see, you can't really see from there, as you can see, when it's on a curve, it can't hit. So I'm switching to the smaller plane. Alright, now as you can see, there's no more topography lines left. We've just we've carved through and met them all. Now you can see how it's there's a definite carve to it. It's gradual, but it is most definitely there. It's 5/8 inch of carve. The next thing that we need to do is we need to perfect this carve. It's very, very rough right now. Lots of plane marks, especially from the cello plane. And we just want to make sure that it looks good. So now this is the part where you got to start thinking and using techniques. One of the first things that I noticed is the center section. I should have extended that a little further. When you rub your hand across it, it goes down, flat, down. And although I want this to go down, I want this to be a continuous arch. As you can see, well, you might not be able to see, but there's a gap right here, so that the high part's over here. So I need to carve this so it's a continuous curve. I'm going to take down a little from the center. Use your hands a lot. Your hands will tell you a lot of things that your eyes can't see. Like, I don't have to put that ruler there to feel, I mean to see that there's a high spot. I can just feel it. Now I'm just using this small plane. It cleans up a lot of what that big plane leaves. Especially if you change directions with it, like cross-hatching. Cross-hatching gets rid of a lot of these marks. Because this thing only takes little bites, and it flattens the bigger bites that the other plane took. And this one, it's small enough, and I've got it set to not be so aggressive, that you really can't head in almost any direction you want. Up grain, down grain, across grain, with grain. It's pretty good. Like I said, that's because I keep it sharp. I have it set to a not so aggressive cut. And it's a small plane. Now, one thing that I have to say to the new builders that are watching this is, it looks... I'm going about this pretty fast, and actually the times when I've had the camera off really haven't been that lengthy of a period of time. So it's actually going very quick, and I didn't do anything fancy or special with the camera off. I mean, there's no tricks hidden in this. And I may make it look super simple by going this fast and this thoughtlessly, but I mean, it is. It's not a difficult process. You should not be daunted by it. This is actually only my third carve. When we're talking about what I've carved, this is number 3. Yesterday, this is number 2. It's an instrument that I'll also be building in this video to show some of the other techniques. And this isn't even finished. You can see there's still marks. Almost done. And this was number 1. And this is almost finished. It's in the finishing stages. But that'll show you that this isn't a difficult process. It's something that anyone can do. And one thing that I have lost that I like to have for the entire carve, because like I said, we're carving into the edge. We want to get back to flat by the time we hit the edge. That's one thing I do miss, is having that edge to look at. So what I'm going to do is, I know that I have a 1/2 inch around the perimeter. So I'll set a compass to a 1/2 inch, have the pin follow the edge, and literally just go around it. And that'll give me back my guitar so I can see what I should be carving to. there's just one spot that is not a perfect half inch. Blank didn't allow it. But let's fill that in. No biggie. So now I can see where I'm going again. Like I said, use your hands a lot. You can feel what your eyes can't necessarily see. High spots, irregular carved spots where it's not a bell. The process is pretty intuitive. It's not rocket science by any means. See, once again, I'm taking down this center part. So my car is probably not 5/8 anymore, but I've taken down the center part a little bit because of that calculation error in my topography. But I mean, it's still a healthy half inch at least. There's no way I've taken down 1/8 of an inch from that center. But we're probably still at 9/16. What I'm doing here is, you really, I can't stress enough, for an elegant looking carve, at least a traditional elegant looking carve. There's a lot of instruments out there that don't have traditional carves, but for a traditional looking carve, you really want this to be ever so slightly flat in the center, then go down, 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 and then start flattening out. So it should be perfectly flat by the time it hits your edge line. And that's what I'm doing. I'm going around this perimeter and I'm flattening this area a bit. But I don't really have it flat right now. And then once I have this area flattened, or almost flat, and flat at the edges, then I'm going to go back and perfect the bell into the flat. That's one of the good things about these curved soled planes, is that when you're in these tight spots where you're trying to get it flat to the edge, yet you don't want a perfect flat, because you got to carve in and curve down. These flat soled planes will get you flat right where the center of it is, but then curve up. So it's really doing a lot of the work for you. And it gives you less to worry about. Doing a little work around these areas to make it curve down into the flat really accentuates the carve in these areas, because the thickness here that it goes down isn't great, but by doing this it really accentuates this area, which is nice. And going downhill, cross grain fixes up a lot of this stuff that I've been doing, flattening the corners, carves it into it. One thing you do kind of gotta watch for is symmetry in your carve. It's especially important in the waist because they're so close together. Alright, let's take a look at this. At this point, you're getting pretty close to what your carve is. We're not at the rough stage anymore. and although we're not quite at the details stage yet. We've gotten rid of a lot of our high parts. It's pretty regular now, and now is about the time where you'll start using the light. I've got a big shop light above my head, and what I'll do, let me turn this camera a bit. And what I'll do is I'll hold it up to the light and look at it, and you can see where the irregularity is in your car. Like, I can see that it's high here. And the silhouette will really help you out. And that's essentially what we're going to do for the rest of the carve. Is we're going to use light as our friend to check out where we've made some mistakes, where we've got to fix, and go from there. Alright, and we're going to continue to do that until we really get the carve to where we want it to be. But as you can see, we've got a nice gentle carve. And believe it or not, this is actually, it's hard to see on the camera. It's a big carve. It's heavier than most commercial guitars that you'll find, at least. Now I'm going to go ahead and, now that you've seen the techniques, I'm going to go ahead and finish this up, and we'll come back in a little while and see the finished carve and get moving on the guitar. One other tool that I found to be quite useful in carving guitar tops is just a simple random orbital sander. Got a rigid one here. When you throw on lower grits, like in this case I've got a 60 on here, yeah, 60, or an 80. I mean, when you're getting that low, you might as well consider this to be a carving tool. And I mean, it'll help you flatten things out, it'll get rid of all these little nicks that your planes have put in it, and it'll really, what it really does is smooth out the surface and it'll allow you to see what you have better in light. And another thing to note is when you're sanding, people tell you usually to keep your sander flat so you're not putting dips in. I mean, literally, this is a carving tool today. Don't be afraid to put it on edge and push down. It really is amazing what a quick pass with the random orbital can do to put your build in perspective. It really cleans things up. Makes it look like a final carve almost, but I went through and got rid of all the tooling marks. That's a great start. But it's also going to tell me now. Well, it's going to be able to. I'm going to be able to feel more where my spots of irregularity are. Because now everything's smooth. Most of the tooling marks are gone. So I have a high spot here. A little high along this ridge here, a little bit high there, regular there, but this one can probably get taken out with the random orbital with a little more work. I'm definitely high up in here, that whole area. We'll put a star in that one. Some irregularity here, and this could probably be feathered more down towards the edge. And I'll either go back with a plane or back to the random orbital depending on what it needs. And here we have it, the finished carve. Obviously it still needs a little bit of sanding. I need to fill these. These are actually worm tracks, but the lumber is perfectly fine. I will be veneering the top, so those will not show. It's got a nice bell curve to it. I'm looking down it and I can see a nice bell shape that it has. I'm trying to get that in the camera so you can see it a little bit. And it also curves delicately and bell-like from front to back. there are still a couple irregularities if you run your fingers across like that. However, we are going to deal with those with hand sanding. Our last and final step on the carve is going to be to get 120 grit sandpaper on a small block. It's got to be a small block, about 3/4 of an inch by 3/4 of an inch by 2, and it's going to be sitting long ways like this. And then we're going to be sanding down at an angle at all, sorry, not an angle, but radially all around, and that's going to perfect any irregularities in the carve. And let me go find that block and we'll get to that. I also wanted to show you the single cut shape that I'm doing, just in case you're doing a single cut. One thing that's important is in this upper bout area, you always want the carve going away downhill from where your neck is. It's going to look extremely strange if you arch up and then start swooping back down by the time you hit the neck. So it'll be a point where the neck meets the top instead of a crest, and that's just an important thing to keep in mind. This is about at the same stage as the double cut top. It needs to have the hand sanding done, and you can see how this maple top here has got a nice curve to it, nice little arch. You can see how the light's hitting that to give you an idea. This is the block that I'll be using. It's just long enough that there's 4 of them per width of a sheet of sandpaper. So what I do is I'll just make quarter sheets, and then I'll get four pieces of sandpaper that fit this block perfectly out of each quarter sheet. No point in wasting good sandpaper. What I've done is I've personally hand planed each of these surfaces so I know that they're perfectly flat. And then I've rounded the edges on 2 of these edges and 2 of the ends. So I've got sharp edges on one side and rounded edges all on the other side. I'll mostly use this rounded edge one. This one, it doesn't really matter. I can use that for concave surfaces, convex surfaces and whatnot, like the crest. But literally all I'm going to do is go through this and start flattening out this car. I mean, not flattening out, but getting rid of any irregularities by hand. And as you can see, I'm going lengthwise in the tighter areas, and as I get out in the wider areas, I can do a little bit of this. I prefer lengthwise for most places, so get a better result. One problem that I kept having with this guitar was that in these 2 areas here, I kept having ridges. And it's not something that I've encountered during a carve before. And no matter what I did, random orbital, plane, I just couldn't get rid of them. Anytime I sanded it, actually made them worse. And the decision I've come to is that this swamp ash has some disparity in hardness and density of the wood in different places. So that reminded me of the last tool that I should probably talk about when carving, a good scraper. Make sure it's sharp, well burnished, but that can get out a lot of the ridges that you don't want in your carve. And I mean, you can use it like this, or if there's ridges like that, you can go down. And it just it's the only thing that really helped me with this swamp ash and that weird characteristic of it. But carve is now done. Alright, now that our carve is done, we need to actually route the body. And like we had earlier, we had that 1/2 inch lip that goes all the way around the body. And what I've done to route this, because I'm using a trim router, is I've taken my template and I've put a little edging of a 1/4 inch nailed and double stick taped to it. That's 3 inches thick, a little bit thicker than our carve, so that the carve won't hit the template, yet we can still keep it attached. I've also used that new template to put a perfect line back, the outer line, and we're going to take that to the bandsaw and cut that out fairly close. The less cutting that your router has to do, the cleaner cut you'll get. Now, a couple things to keep in mind. If you're doing a one-piece body where the carve is part of the body piece, i.e. you're not gluing a cap on, when you attach your template with a screw there and a nail here, you need to keep in mind where it won't mar your top surface. For instance, this will be routed out where the neck will go in, and this is the farthest most pickups center. So those are important things to keep in mind. Whereas if you're just doing a body blank that you're going to be gluing your carved top on, you can just put your attaching things wherever you'd like. Now a little bit about the bit that I'm using. It's a white side bit. It is huge. It is a shear cut. You can see how it's got the angle to it. This reduces chip out, which allows me to actually take the whole thing in one single pass, which gives a nicer surface. And also it makes it so that I don't have to do any cleaning up of this, because often if you do it in steps, there's slight differences in the router, and it makes cleanup a pain. Alright, well, one thing I like to do is I like to start off in these high points and go down like this, pushing it that way. If you come into this high point, it doesn't have much support on this side, and you risk chipping out the edge there. So always start at your highs, go down, and then you can, start at your highs, go down, and then you can come back at them from the other side. Alright, now after you've checked that your bearing is riding your template and the cutter is covering all of the wood, let's get to work. And here is how nice a surface that this leaves. Look at that. There's where we started, and look at that. Cutting the binding channel on a carved top guitar can be kind of tricky, because usually when routing it's nice to have a flat surface so you can just lay the body on the table and go at it. One way that you can get around this is building a jig like this. It essentially registers the body off of this flat surface, and then you have your binding cutter riding from the top. That way the carved top has space to go underneath the jig, yet it can still route at a constant level. And I'll show you how to do this in a second. It's a lot simpler to be binding a flat top guitar, or if you're binding the back on your guitar, you can simply put the router into a router table and use it just like any other router. As you can see here, I've already done the back binding ledge, and that turned out great with just a flat surface. Now, one thing to make certain is that your height is adjusted correctly. So just by looking underneath, you can check that this is done correctly, and then you can go at the task. And I'm going to show you just a bit of it, and then I'm actually going to turn off the camera and finish it up myself. Once you see one pass, it's not going to seem too terribly difficult. One thing to keep in mind though is always keep pressure close to the bit, so that your body is always registering flat on your flat surface. And once again, just like we did when we routed the body, you want to start at the tops and go down and then come into the tops. And here you can see the results, both my binding channels, bottom and top, and also notice that I've done a purfling channel. This is done in the exact same method that you did the binding channel. It just uses a different sized bearing and depth, obviously. for bending wood bindings, you're going to need a couple tools. This is a bending iron. You can actually make them with a barbecue lighter and a metal pipe, but I like the fact that this has that shape to it, and I'll talk more about why I like that versus a standard round pipe later. It can also be made with a blowtorch and putting the fire into the pipe and obviously putting a cap on it so you don't have flames coming out the end. Pretty much you just want a heated pipe. And here we have distilled water. Normal water works, but some wood will be colored by it. I just find that I like distilled water. Don't ask me why. The way that wood bending works is heat and water. So essentially what you're going to do is you're going to measure out where you need your curves on your guitar, on your stick of binding, and you're going to wet it down. For especially difficult woods, such as curly maple like this, it's sometimes a good idea to buy a product called Super Soft 2, and it's a product that's used for veneer work, but it also seeps into the wood, makes no permanent physical changes to it, and helps it bend. So all you're going to do is essentially you're going to heat the wood with the side of the iron, and once it gets hot you can start to feel it give. And essentially the way that you want to approach this is to heat and pull into the tighter curves. That's why I like the multi radius pieces instead of just a circular pipe, because you can keep it on the flatter parts, and as it heats, pull it into the tighter curves. For especially tight turns, you want a backer. I find that just a 1/4 inch wide measuring tape does fine, and you're essentially just going to hold the measuring tape to support the back while pulling from both sides like so to keep pressure, and that helps keep pressure on the outside of the wood so it doesn't blow out the back when you are bending. Remember that your water will evaporate off because of heat, so keep putting more distilled water on as you go. I'd suggest practicing on some pieces before you approach the actual project, because this is a learned skill. It's a difficult thing. This is why a lot of factories do not do wood binding. It's time consuming, it's slow, it's arduous, and you will crack pieces. So don't start with expensive binding. Expect to get it right the first time. Some easier woods like rosewoods, walnut, myrtle, holly are going to be better to start with than brittle woods like ebony, figured woods like curly coa or curly maple, and an especially difficult one is bloodwood. It wants absolutely no water. If you put water on bloodwood and try and bend it, it will crack on you. Don't ask me how I know that. Remember to check with your routes and on your body to see how you are coming along with your bends. Before we can actually glue up the binding, we need to put everything in place with some tape around the whole guitar body so that the binding comes to where it should, well, where the binding is going to go to. As you can see, it hangs over my center line by a little bit. We're going to need to trim this up on both sides before we can actually glue the binding. See, both sides hang over. For this, it's essential to use a sharp chisel. There's really no other way to get it good. And I like to keep the binding on the guitar so that I don't have to re-tape it every time. And what I can do is simply get a block or two, raise it up, and then a sharp chisel. If it hangs over a lot, I can nip it with some fret nippers up closer to the line, but as I get close to the line, take tiny bites off with the chisel. Perfectly 90 degrees, well, obviously I'm going to have another block here to keep it up, but perfectly 90 degrees up and down, and left to right. One way to make sure that you're 90 degrees like so is in the back of the chisel. If it's well polished and sharpened, you'll be able to see the reflection of the part hanging out this direction. If you can make the line on the actual binding and the reflection perfectly straight, you'll have a 90-degree cut. To pre-bend your purflings before gluing up the binding, they're a lot simpler than the actual wood binding. They're made out of a very pliable material. I actually use maple center stripe, and then they call it fish paper. That's the black. It's a fiber type of composite, and it's only 60 thousandths thick. So I mean, you can bend it quite easily without it doing anything. What I do to pre-bend my bindings is I simply wet them and slowly bend them into the shapes and tape them as I go. And then a place like the waist, I'll pull out like this as I bring it in to overbend it a little bit, and then I'll tape it up. And when the water that I've put on these dries, it'll sort of lock in the shape. But I mean, purflings are so pliable that they don't have to be a perfect bend, because the tape will easily keep them in place and they won't cause problems when you're doing your glue up. In preparation for binding, we're going to perfect these binding ledges with a small file. The binding cutter does a pretty good job, but it doesn't always do it perfect. So just bring around your file, and I've flattened one of these edges so that it doesn't cut into the body when I'm filing. And just go around and perfect the ledges. Just give them a nice flattening. And go all the way around the body with both the binding ledge and the purfling ledge. As we talked about before, there's two different ways that you can do side purflings on a guitar. As we saw earlier, I can attach them already so that the purflings are already on the binding when I bend them, or I can glue on the purflings afterwards. This is the bent binding for that horn in the lower bout, and this is going to be the purfling for it. It's not actually already attached. We're going to glue that separately while we do the binding job. I find generally that this first method is easier because it's one less thing to worry about gluing up in the mayhem that is binding a guitar. However, if you do attach the purfling to the binding before bending and before gluing, you need to come around with a razor blade and scrape that inside edge that will meet the guitar. If there's any burrs in this purfling, then it's going to make your binding stick strange. So we're just going to give that a light scraping, make sure everything's good, and then get to binding. I'm going to talk a little bit about the methodology of binding, mainly because I'm not actually going to film myself doing the binding job. The reason for this is has to be an extremely fast process in order to get everything tight and squared up before you glue. But I am going to show you the techniques for doing this binding, as well as when I've done all the binding, I'll turn the camera back on and I'll show you how it looks while it's drying. It's actually pretty interesting. What you're going to do is you're going to start by putting glue all around the binding ledge. And also, if you're doing top purflings, you're going to put glue on one edge of the top purfling so that it'll stick to the body, and also have glue on this side. That way, every surface that's touching another surface has glue on it when everything is put together. Then, using something called butcher's tape, it's this brown, almost papery, wax papery feeling tape that's extremely tacky. It's extremely strong tape as well, and that's why we use it for binding. What you're going to do is you're going to start with any ends that meet in our case, the end down at the back of the guitar. We're going to start gluing there, and we're going to attach strips of butcher's. Obviously, we're going to put purfling in as well, with all these ends mitered correctly. And we're going to line everything up. And now you see why I don't plan on filming it and talking while I do it. Either way, so we'll line everything up perfectly, and we'll place a piece of butcher's tape. What we're going to do is we're going to push it down on here, and then leverage it up and over, and as we come over, pull and tape so that it puts pressure going inwards. The next one we're going to start on the top and put pressure going downwards and tape. And we'll just alternate these as we go along so that the pressure is going in and down, in and down, in and down. And this is what's going to keep our binding flush to both the top and the side. And here's what it looks like with the first side glued up. I like doing one side at a time. It lets me get to everything faster. As you can see, I started with the butcher's tape, strapping it down, and then strapping it up, strapping it down, and strapping it up. And once I had the tape all the way around, holding everything in place and keeping everything in, then I went back and I went all around this to hit all these areas and pull it in tight with this product. Heavy Duty Jute. Seems to work pretty well. One thing I do want to warn with this is prepare to get glue everywhere. I mean, you're just going to get all over your hands, for one, because you're messing with the bindings that have glue all over them. And then also, when you're putting the jute on, you're using your body as leverage and pulling the jute to get it taut over these edges. You want the jute to have some force to it. So you're actually pushing the body up, this body up against your body, and leveraging to pull the jute in, or jute, whatever. And so you're going to get glue all over yourself, so be aware of that with whatever you wear. Binding glue-ups can also be done using the super glue method, and for this we're using what 3M markets as extreme packing tape that I've just cut into small strips. And as you can see here, I've done a binding job with plastic binding instead of wood, and this is one area where the super glue binding method works pretty well because obviously Titebond is a wood glue and it will not adhere to plastic. Another area where the super glue method is a nice way of doing things is where you have a complicated layup with multiple layers of purfling and whatnot that may be difficult to glue up with Titebond in a expedient fashion. There are also other ways to do plastic binding with contact cements, specially formulated for wood to plastic glue up. However, I find the super glue method nice because it allows you to tape everything up, make sure everything is tight and in place, and then using thin super glue, you simply flood the area of the binding, and this thin CA will seep down into all the cracks between purfling, binding, the body, and whatnot, and glue everything tightly in place. Now after you've got your binding glued up, it's going to sit probably a little proud on the edges as well as on the tops, unless you had things absolutely perfect. But I'd rather do a little scraping than risk my binding being too thin or not tall enough. So what I do is, for flat tops and backs, this is a little easier because you can use a normal scraper. You don't have to worry about scratching your top or anything like that. But for a carved top, I use a scraper just like this. It's called a French curve scraper. And as you can see, it's got these, I don't know what to call them, but just these curves that allow you to get here get your binding without marring your top surface. And depending on where the curve is and how tight things are, I'll go to a tighter radius to scrape and whatnot. I like to do the top of the purfling first, because with a carved top, what a lot of people tend to do is they'll actually tend to angle the scraper down a bit, and you'll end up with not a perfectly flat, and that's fine, because we're going to round over our binding ever so slightly, But just to add to my safety precautions, I'll usually flush the sides of the binding afterwards, so that if I really dig into a corner, it doesn't matter because I'm losing a little bit of that corner when I flush up the sides. And it's really just a simple process. It takes a little time, but just something you gotta do. Literally just going to scrape. You can see these shavings coming off. And slowly, bit by bit, just work your binding down until it reaches the top. And one thing that's really important is to have a very flat surface on the edge of your scraper. One way to do that is I like to cover the edge in Sharpie, and then I'll either take it to my disc sander or with a hand file at perfectly 90 degrees and go along until all the Sharpie's gone, so I know I have a flat surface. And then you take a burnisher and just burnish an edge so that it's got a little, you can feel it, it's abrasive. And that will help make this go faster. And here's how it should look when you're done. All the binding and purfling is flush with the top. And it's, with a French curve scraper, since it's got those curves, if you're expecting everything to be perfectly flat, blah blah blah, if you run your finger along it you feel no dimples, no nothing, you're kidding yourself. I mean, I'm sure an amazing craftsman could achieve that, but the point of this activity is exactly what I said, flushing the binding to the top. Later, as you can see, we've got some glue on the top, everything like that. I mean, before we finish this guitar, we're gonna have to sand it with a random orbital sander. And when you come across this with 220, 320 on your random orbital, and you hit these edges, it's going to perfect everything. So really, when you're scraping, you're looking to flush everything up. That's it. Now, to true up our binding on the sides, there's two ways you can do this. And the way that I'm going to show you is ever so slightly controversial. Some people don't like to do it because they don't want to risk blowing out their binding after all that work they've put into it. But you can do it with a router. Have the bearing follow your body side, and the cutter will cut obviously to match the body, and that's perfect unless you've got a really figured wood. That's the only time I won't use this method. Like if I have flamed koa or flamed maple binding, just the flames make it so dangerous to do this because it's more likely to blow out the figure. But on a wood like ebony, perfectly fine. If I were to be doing this on a guitar with flame maple binding, I would do it by hand with a scraper, just like we did on the top, but obviously on the sides, and I'd use just a standard square cabinet scraper. Another good option for those that aren't planning on binding their guitars is a roundover. Creates a nice rounded edge to your guitars so that it's not digging into people's arms when they're playing. Obviously, if you're doing a binded guitar, this isn't an option because you'll round off your binding. But on the back of guitars, I usually put about a ½ inch roundover. And then on this guitar here on the bottom, I'm going to go ahead and put a 3/8 inch roundover because my top is 3/8 of an inch thick. I'm going to put it on the top and the back. I don't want to round into this nice maple purfling line that I have underneath the top. But we're going to go ahead and give that a shot, and I'll show you how to do it, and you'll see how nice it looks. You'll hear a lot of people talking about when doing a roundover, because this is a fairly large router bit, they'll take a roundover pass in multiple passes instead of just putting the roundover in at once. However, I found if you've got a decently powerful enough router, and my Bosch 1617 seems to be powerful enough. It seems to be able to do it. You can look up online to see how powerful this router is, and that will give you a better idea. But these powerful routers seem to be able to take a full ½ inch roundover in a single pass. Any more than that, I'd probably step it up by either doing half of it and then raising the bit, or you can start with a smaller roundover, say 1/4 inch round over, then do a 3/8 inch round over, and then do a 1/2 inch round over to build up, so you're not taking off all that material at once. Like I said, Powerful Router seems to be able to do it in one pass, and we're going to do this just like we've done every other routing operation. Start at the peaks, go down, and then work back up towards the peaks. And as you can see, that rounds things over really nicely, and it leaves a comfortable guitar to play as well. I don't let the router do the full pass. As you can see, I leave it so that there's a slight angle, so it's not a perfect round over. I found that I do this because just small differences in the guitar when you're routing and your table and whatnot can make it so that if you put your router ever so slightly high, you can look on the bit, it goes round over and then straight down. So if you have your router bit too high, it'll actually cut into the flat of your wood. So I find that it's simply easier for me to route it and leave a little bit to do by hand than to have it gouge my wood. Next, we're going to be making a neck template that will make the taper of our fingerboard and neck. And as you can see here, I've done a full-scale drawing of what the neck will be like. What I've done is I've put a center line and marked where my nut will be, and written that it is a 25.4-inch scale fretboard, like on Martin guitars. That is where the nut is. And then go down all the way here. I've measured where 25.4 is, and that would be the bridge. So then I'm using a bridge that has a spacing of 2 3/32 of an inch string spacing. So I've made this line 2 3/32 of an inch, and I've come down here and I want a 1 3/4 inch nut. However, that's the actual nut, not the string spacing. Down at the bridge we have a mark for the string spacing. Up at the nut we have a mark for how wide I want the nut. So what I've done is I've brought each side in 1/8 of an inch. So the two E strings are going to be 1/8 of an inch inside of that 1 3/4 inch nut width. And I've connected those points to the string spacing on the bridge. Then what I've done is connected the end points of the nut width down here. I've added 1/8 of an inch on either side, and that makes it so that we have the inner lines are our strings path, and the outer lines are now what our fretboard will be. We'll transfer these lines onto some MDF and we'll go ahead and cut out the template. To make the template, what I've done is I have made a kind of shooting board for my table saw. It has these hook on, these screw on sort of hold downs, and what I do is these keep the piece flat and it simply rides along, and I made the board and then sent it through the saw to ensure that this edge was perfectly aligned with this blade. So then what I can do is I can follow my lines on my template, line those up with the edge of this board, clamp everything down, and then just send it on through. The next step in the build process will be to start our neck. Now what I have here is I have a white Limba neck blank that I'm going to be using for my neck, and one thing that I always do is I like to plan out where everything's going to be, and as you can see there's a bunch of marks down this neck blank. That's because out of this 2-inch thick blank I'm actually going to get 2 necks. And what I've done is on each side I've listed where 2 inches is, because I like to have 2 inches of tenon extending at the end of the fretboard that we're going to route or pick up over, so that's fine. 2 inches there. Then that's after this 2-inch mark is where the fretboard starts. I'm measuring 24 frets just to be safe in case that's what I want to use on the build. and I'm measuring where the neck connects to the upper bout of the body, i.e. where the heel is going to have to go to. Then all the way down here, this is where the nut is. That's a full 24 frets at 25 inches. That's what that means. So that's where the nut is. And I measure 7 inches from my headstock. That gives me an inch of safety. Now the reason that I'm not measuring for a scarf is because when you cut a scarf out of a 1-inch board, it comes to something like 4.44 inches or something like that, if I remember correctly. And what this does is actually it comes to 4.44 inches if you do a 13-degree angle, which is going to be over about 4 inches. So you're actually gaining some. So if I measure the full length of the headstock, I don't have to take into account the scarf, because by scarfing I'm actually adding distance. And then I've also done the second side. So we have, once again, 2 inches, 16th fret, the nut, and 7 inches of headstock. I've also got a center line, and that is going to be where I rip the board, except for where the heels are. So what I'm going to do is, just because the neck connects at the 16th fret doesn't mean that that's where the heel ends. So what I'm going to do is I'm going to take the 16th fret mark and the 17th, and the end of the headstock of the neck above it, and I'm going to choose a spot that fits well. So something like that. So that gives me my full length for my headstock with a little extra, and for the neck on the bottom, it's giving me my heel with a little extra to play with. And what this is going to do is that I'm going to cut along this line, follow the center line all the way down the neck, and then once again cut on a similar line like that. Before we start cutting this out on the bandsaw, let's go over a couple things. I found that out of all the tools in your arsenal, a bandsaw can be one of the most helpful, but also one of the cruelest mistresses. So spend the money, get decent blades so that they don't wander. The first time that you ruin something like an expensive neck blank, and I speak from experience, you will have paid for a more expensive blade. So it makes no sense to buy cheap blades. Companies like Timberwolf, Woodmaster, they all make great blades. But let's talk about guide bearings. You should have your rear guide bearing. It's hard to see, but it's set so that you can see the light coming through between the bearing and the blade. It's set so that it's almost touching the back of that blade. And these are set right behind the gullets with about a paper's thickness between the blade and the bearings. And then we've done the same thing on the bottom set of guides. It's very important to set these up correctly. I'm stopping at this point for 2 reasons. The first reason is you can't see it, but the neck blank is too long and it's hitting something on the other side of the bandsaw. I don't have a huge shop, so it makes things like this a problem. Also, if I were to have continued and swung this way, eventually that other end of the neck would have hit the stock of the bandsaw, because this is only a 17-inch bandsaw, so that means there's 17-inch clearance between the blade and the stock on the left side. So what I'm going to do is I'm just going to turn the saw off, back the blade out, and just come at this from the other side. You can now probably visualize a little better what we've done. You can see the cut, it goes along like so, and we have our two neck blanks. They're going to be scarfed, that's why this is allowed to be that thin, but we have a one-piece heel, which is going to be a nice look. One of my pet peeves is seeing a stacked heel line where they've laminated an extra piece on to get the thickness. Why not just buy 8/4 and do this? And we'll be hiding the scarf in veneer on the headstock and a backstrapping veneer. Now that we have our neck blank cut out, we need to figure out where we're going to put this scarf. There's two different ways to do a scarf joint. You can either have the scarf cut and then put this on the bottom and have that be the second part of the headstock, or you can cut the scarf further down here, flip it, and have the scarf be in the neck. Obviously, if it's in the neck, after you've carved it, you're going to see a parabolic shape in the back of the neck like you see on guitars such as Ibanez and the like. Whereas if we're going to be veneering the head plate and the back strap, it's very easy to hide this scarf in the headstock. So since that's what I'm going to be doing, I'm going to put my scarf in my headstock. And as you can see here, I've written that this blank is exactly 31/32 inch thick. So what I can do is I know that I need a 13-degree angle, and that's this angle here, same as there, since these are parallel, these faces. So that's 13 degrees, and that's 13 degrees. And knowing that, I can take 31/32, 13 degrees, and I can find out the length of this section so that I can draw this accurately. And what I've done here, I've just drawn a triangle, and it has these different measurements. And as you can see here, I just used a little trig to figure out that that length should be 4.19 inches, or 4.2 is accurate enough for our uses. Now I can take it to the bandsaw and go ahead and cut that out. So there's a couple ways that you can do this. I'm going to show you a little bit of both ways that I use. We're going to start by I flattened this out because if you remember, this was the bottom of our cut when we cut out the neck blank. So this was also rough from the bandsaw, so I just flattened this out. You can do that with a hand plane, your sander, whatever, it doesn't matter. And you also need to do the same to the back of this. This is the tricky part, because you can't just send this through your sander because you've got this thick heel. So what I'm going to do is I'm actually going to go back to my safety planer. I'm going to safety plane that up. So now that both of our surfaces that were once uneven are now even, we can take these and match them up so that the angles are going together. And what we're going to do is, this is flooring tape, Duck brand flooring tape. It's extremely strong. It's this weave pattern. I mean, it's strong enough that you can actually use it instead of nails and stuff when you're doing templates. It sticks real well. It just takes a little bit. So I'm going to cut this in half, and I'm literally just going to double stick tape these two together. Like so. Alright, and that's what we now have. Next we're going to go to the joiner, and you may be saying, well, don't joiners need long pieces of wood to go through them? Check what the minimum distance your joiner can take is. Mine can take 6 inches, And as of right now, this is now a 7 1/4 inches long. So this can actually go through the joiner. Obviously use all the safety precautions when using a joiner. You don't want to mess anything up. But let's get over there. Hold it flat against the fence, because if this isn't flat, it may skew your scarf, which is a bad thing. Switch this around a bit. After the first pass, it's already looking better. We're going to do this until we have a relatively good surface. To finalize this scarf, the joiner does a good job getting rid of a lot of the rough stuff, but it's not in this case, it is not a fine working tool. So what I've done is I put a little spacer here to make this thickness the same as the heel. Clamped this down, and it puts pressure on this board to keep this in place, and now I'm just going to use a number 5 smoothing plane to perfect my scarf angles, and then we'll go to glue up. Now we're going to be gluing up the scarf joint. A lot of people seem to have problems with this. I know I did when I first started. It's a little strange to be gluing something that's this pointy, as well as has a tendency to slip around because of the lubrication of the glue. So a guy named David Mike actually taught me this technique, and it seems to work pretty well. I'm happy with it so far. And what we're going to do is we're going to lock that end of the neck blank down with a clamp so that it's not going anywhere. Then what we're going to do is we're going to apply glue to this surface here, put it there to about where we want it so that it's not moving either. Clamp this. So that means both of these are not going to be able to slide. And then we're going to use clamping cauls, one for the back, and then the one that we do on the top, since this is where the joint is, glue can squeeze out here. So we're actually going to cover this in tin foil or wax paper works so that our caul does not get glued to our neck blank. And then we're going to use a bunch of really nice hard clamps to clamp that in place. When it comes to tight bond, you can never have too many clamps. It's just a rule. Epoxy, not so much. You can have too many clamps with epoxy. Wood glues, nope. And here's what it should look like after the clamps come off. If got a little glue here, or one part sticks out more than the other, you can send this through the joiner. And keep in mind that every time you send the face through the joiner, the face of the headstock, it moves this line here, your nut line, further forward this way. So each time you plane this, you lose a little bit of length. Whereas each time you plane the face where the fretboard goes, you gain a little bit of length. So if you've got a thick fretboard, a thick neck blank, you can actually regain some of the distance on the face that you lost during the scarf by sending it through the joiner, or if your nut is too far away from the end of your board, then obviously if you've got enough heel, you can just take it off at this end. If you don't have enough heel, you can just plane the face. Another nice glue-up method that's especially fun for when your headstock piece may be a different width than your neck piece, in cases such as where you have a thin neck blank but you still want a one-piece headstock without wings on it, is this tape glue-up method. And essentially you just line everything up, put pieces of tape, and then you can flip it up, apply your glue, and then clamp it just like normal with a flat piece here and clamps, but you don't have to use your table to keep everything aligned because the tape is doing that job. Once you've decided that the face of both your fretboard surface and your headstock surface are how you want them, the distances are correct, go ahead and draw a center line down the whole entire length. I say the whole entire length because you're going to lose almost all of it along the face of the fretboard when we put in the truss rod. All that you're going to be left with is this small section down the end here as a center line. And that's why I do it all the way down that end as well on the headstock, because having it on the headstock we won't lose it and we'll continue to have a center line, and that'll help us out later. Now what we're going to do is we're going to be routing this truss rod cavity with a 1/4 inch bit. That doesn't necessarily mean your truss rod will take a 1/4 inch slot, but the LMI truss rods that I'll be using take a 1/4 inch slot, and therefore I can do it with a 1/4 inch bit. What I've done is with a piece of wood, I simply put this up against here to find out where the end of the bit is and mark that on my fence. I've also marked where my truss rod will end. My truss rod is 18 inches long, and I want the adjustment to be right under the nut, not sticking out further. This is just a preference thing. You can have it stick out further, you can have it be further in, that's fine. So I measured 18 inches from exactly this point to there, and I will transfer this line onto the side so that when I start routing this, wrong direction. When I start routing this, I can route until the line and the tape match up. Now, as always, there's more than one way to skin a cat. We could have also done this with a fence and our table saw, and then simply put a filler strip in behind here to fill in the part that we didn't want routed out. Both ways work. I just like the router bit because it gives me a perfect 1/4 inch slot, whereas on the table saw I have to do a little bit more measuring, a little bit more fandangling to be assured that it's a 1/4 inch. However, the table saw version does have the added bonus of being able to be perfectly centered, because you can send the neck blank through one direction, flip it around 180 and send it through the other, and that perfectly centers it. Whereas this, I've had to measure. I put my center line on the end, and I have made it so that the center of this bit matches up with that center line. I mean, it's just two different ways of doing it. Both of them work perfectly well. And what we're going to do is we're going to route in small increments. As you can see, I don't have it set very high, and that's just going to be my first pass, and then I'll take slightly more aggressive passes as I go, but the first one especially I want to take small, because if there is a mistake, it's not the end of the world if it's just a small pass. I also should have mentioned that by this point you should have jointed the edge that you're going to be following along the face so that it's perfectly flat, so that you don't end up with any mess ups later on, just in case it wasn't perfectly flat. And I've gone ahead and made sure that this opposite edge is also jointed, not because it has to ride along any fence or anything, but I wanted to make sure that the blank was the same width here as it was down here. Let's get to routing. This little test cut, as you can see, it is perfectly centered along my line. So let's go ahead and do the rest of it. And we're going to go ahead and continue to work exactly like that, raising the bit as we go. Doing about I don't know, 1/8 of an inch at a time, maybe 3/16. And what I'm going to end up with is I'm going for a slot depth that's 0.4 inches deep, because I'm going to put a filler strip on top of the truss rod, and that's what I'll be showing in this video. It helps to reduce rattle in the truss rod later on, but that by no means is a must. You can do it to the exact depth of 3/8 that the LMI truss rods are, and that works fine as well. I like the filler strip because I said it reduces rattle a bit, and also because it makes it so that I don't have to be as exacting as perfectly 3/8. I can make it a little more than 0.4, a little less than 0.4, because no matter what I do, the filler strip's going to go on top and fix all that up. However, if you are doing a really thin neck, like say something similar to the Wizard necks, very, very thin for fast electric playing and Steve Vai style stuff, then you're going to have to go ahead and do the 3/8 and forget about the filler strip, because you're going pretty thin on that neck. And we'll come back when I am done doing the routing. And here's our finished slot. And just something that I noticed while I was routing, so I'm going to change my advice a little bit. Having that tape there, it started to bunch up, which affected my slot here at the very top. I noticed it before it got very far, so I actually took the tape off and instead drew a line in just pencil on my router fence, and that seemed to do a great job. Now on this other neck blank, we're going to give the table saw approach a try. I've used a scrap piece of wood to ensure that it's a 0.4 inch deep channel, and I have once again found the center. Although, like I said, in the table saw version, it's not as important, but I'd like to start on the center. And then what we're going to do is with each, I'm going to send it through this direction, come around, flip it, send it through that direction, and then I'm going to push this fence in ever so slightly and do the 2 passes again, push it in 2 passes until I get a 1/4 inch wide ledge. And there is the first pass. I'm going to continue doing this without the camera, and we'll come back when it's done. The next step we're going to take is to go ahead and slot our fretboard. What I've done is I've taken my fretboard blank here. This happens to be some black and white ebony. And I've made it about a little over the maximum width of our fretboard, which brings this one to about a little over 2 1/4 inches wide. And I've squared both sides, made it so it's the same width all along the blank. And I've also thicknessed it to a 1/4 inch. And what the next step is going to be is we're going to put the fret slots in here. I'm using a template that is available at most Luther supplies, and it goes with what I have under here, which is a fret slotting blade. It's a very thin kerf blade that is perfectly sized to be used with the fret wire from Luther supplies. And I've just, once again, you can see a little remnant of it up here. I've attached it with that carpet tape, that really strong carpet tape. And really, all that you need to do is come along. I've got a pin in this jig, and it's a very simple jig. It's just a kind of like a shooting board, just some plywood with 2 rails to keep it together, and then I've sent it through to put the line for the saw to go through, and from there I just set the height appropriately, and each time I do something, this little pin notches into the template, and so I'll send that through, and then I'll re-notch it, hold it against, send that through, and so forth until I get all my frets done. finished product. Before you go ahead and take your template off the board, however, make sure that you haven't missed any slots somewhere. It's a pain to get it lined perfectly back up again. And make sure that your slots go deep enough. As you can see, it's easy with this one because this is actually a laminated board. I wasn't 100% sure about this new black and white ebony, so I went ahead and laminated normal ebony for half of the thickness. And as you can see, the slots go exactly half deep. So that's 1/8 of an inch. That's perfect. Yep, and that's really going to look stellar. And one thing to keep in mind, you don't have to have a table saw or that fancy blade to build a guitar, because you can get fretboards pre-slotted from Lou 3 Supplies. You can actually get them pre-radiused as well. And they also sell hand saws that will do exactly what that table saw blade did. I actually have one of these hand saws right here. It comes with a depth stop, so that I've cut that out so I can have a small saw on the end. But they come without that, and they've got a depth stop so you can set how deep you want your frets. And it also comes with a jig that uses the same template as I used, but works with that hand saw. As you can see, I've done a couple things off camera, but it's nothing that you haven't seen before. I've taken my template and I drew out all the lines on my necks, like so. You can see the lines. And I then just went to my bandsaw. You could use a scroll saw, jigsaw, handsaw, and I've cut it out. I've only done this section of the headstock template, and you'll see why later when we veneer the headstock. But in order to have my saw come out, I had to go somewhere, so that's where I went. And as you can see, I've done very, very close to the line. The less your router has to do, the better. I've once again attached the template with double-sided carpet tape, and I've installed a 3/4 inch diameter template bit that the bearing is going to ride our template, and I've set it to the height to cut through our neck, all in one pass. That is a key feature. It's not so important along the neck since we'll be carving that, but when you get into the heel, if you try and do it in multiple passes, just like we talked about with routing the body, you can get lines where it's not 100% even if you do it in multiple passes. And this is especially important in the heel because that's where it's going to be going into our neck pocket, and any discrepancies there will make an ugly neck joint. Because you're going to be routing this in one pass, a sharp, clean bit is very important. Even a little resin trapped on this cutting edge here can make a small line on your neck. I mean, you can sand it out, but why if you don't have to? So always use a relatively new bit, sharp. You can resharpen these, so that works too. And I always clean it with some router bit cleaner before I start. And as you saw, as always, we moved against the direction of the cutter, even if that meant going uphill along the neck. But because this is such straight grain, going uphill on this, I've never had any problems with it. Next, we're going to do the fretboard the exact same way. As I mentioned before, a perfectly acceptable way to do it is to attach the fretboard to the template we just used on the neck. But you can also just switch out to a template bit, sorry, not a template bit, a flush cut bit, and route it on your neck, like so. One other thing I should mention, as we know, this tape is extremely strong, and since we have frets cut into this fretboard, try not to pull it off like that. Instead, this tape doesn't react well to torsion. So you can actually hold the fretboard and push like this to get it off instead of ripping. I like a nice bound fretboard. It covers up the fret the fret slot ends and just makes the neck look cleaner. For this board, I'm going to be binding it in just straight ebony, no purfling. And one of the things that I like to do is you could simply just glue the fretboard on and use a binding bit just like we did with the body and go from there. But I found that since the fretboard is a straight edge, I can clamp it back into my shooting board jig, but clamp it while holding a piece of binding onto the ledge, so that when I remove the binding, its thickness is what the blade will cut off. And from there I can just send it through the table saw, flip it around, do the other side, and glue on the binding. So after we trimmed this board to accept the width of the binding, I went ahead and just mitered the ends. Same technique as we used doing the straight cuts at the tail end of our body, but this time instead of trying to make a straight line in the reflection on your chisel, try and make a 90 degree reflection in your chisel. That will mean you're cutting a perfect 45. The fretboard has a taper, so it's not exactly a 90, it's actually a little less. So use reflection to estimate a little less than 90 degrees and just play with it from there. Now we're going to glue these up. It's a pretty simple process. I tape it so that everything is where it's going to be, and just make sure everything matches up lengthwise and whatnot. I like to put the back end in first because once this is installed, it gives you like a positive stop that you can push these side rails up against you, and it just makes for a more accurate glue job. We're going to be using the same technique as we used to bind the guitar's body, in that we'll just put a little glue and then use some tape to secure everything. You can use the same tape that we did the guitar's body binding with, but that tape seems to be more difficult to find, and it's also more expensive. So since these are just straight pieces, there's not much that can go wrong, and you don't need a lot of pressure to keep everything in place. I just use normal painter's tape. Alright, now that that is in place, we can remove these side rails of the side binding and add some more pieces of tape to pull this in. The great thing about binding a fretboard in this manner is that the tape, if you do it correctly and just pull down, it pretty much centers the binding strip for you. So you don't have much to worry about it sliding off to one side or the other. I mean, we're going to come back with a scraper and scrape the bottom parts that it's flush to fit onto our neck, but this does a pretty good job of keeping everything where you want it. So now that we have our positive stop, we can start putting on the side pieces. For this, it's a little bit more complicated because of the fact that you have your fret slots on either side of the binding. And the reason that is an issue is because if you put too much glue, then you'll have glue squeezing into your fret slots. I mean, you're going to have a little bit of that anyways. That's why I keep this X-Acto knife here. But too much of it and it's just going to cause problems. Alright, now I'm ready to go. We're just going to apply glue to the miter and all along the edge. Apply it sparingly so that we don't have a lot of squeeze out into the slots. This isn't a structural joint, so you don't need a whole bunch of glue to keep this binding in place. You want just enough to cover the surface, and that's it. That's the amount of glue that you're looking for. Now you can just slide this piece up to the joint and go ahead and start taping stuff in place. And like I said, the tape should center things pretty well. There you go. The first one's always the most difficult of them. But, I mean, difficult in this sense is very relative. So there's my first one. I can just go at it from there. Then what I'm going to do is I'm just going to come around with my X-Acto knife, and even the little bit of tiny bits of glue, just pull it out with the X-Acto knife, just wipe it off and go to the next one. Here you can see the board fully taped up and ready to go. If you look closely at the tape, you can see where I've stuck through with my X-Acto knife to pull out some of that glue. Another thing to keep in mind when binding fretboards is if you're binding it in the same wood as the fretboard, especially with woods like ebony, then you don't actually have to do a mitered end piece. As you can see here, the binding just goes straight and there's no end piece and less work. Obviously I will chisel away that glue squeeze out, but the ebony just blends with the fretboard, and you end up with a perfectly nice bound fretboard without having to do the extra work of the end binding. The next step is to clean up the binding on the underside of the fretboard, because unless your binding was the exact thickness of your fretboard, when we did the glue up that centered the binding on the edge, it had the exact same amount hanging over the back as the front. So we have to clean this up before we can glue it onto our neck. And even if it was the exact thickness, there's still glue poking out from a little bit of squeeze out and whatnot. So I'm taking a freshly sharpened scraper, and we're just going to go over it and screw everything up. And we'll just do that until all the binding is flush with the fretboard. Now, if you have a non-pre-radiused fretboard, then you can get this almost perfect and send it through your sander. First using the side that you've trued up as the reference on the bottom, and then once the top is good, flip it over and perfect the back with your sander. If it is a pre-radiused fretboard, you don't have that luxury, and you're going to have to get everything trued up perfectly by hand, because you can't exactly send a radiused fretboard face down through your sander. Alright, and the next step is going to be to install our truss rods. These are the rods I'll be using. They're the LMI double action. They have a threaded end and a reverse threaded end, so that when you turn them, it expands the rod. They've got a flat top and a round bottom. There's a couple things that you need to do before you install them though. One is to remove, you can see the bump here from the weld. A simple file with a couple passes will do this. And just do that until the weld is gone. And then the other thing is always rigorously test a truss rod before you use it, just clamp this end in a vise and give this a nice turning. Better to have it break now than while it's in your neck. Also, because we routed this, there's a rounded end down here from where the router stopped. I'm going to go ahead and square that up with a chisel and put the truss rod in. When I install my truss rods, I like to do something that prevents them from rattling a bit in the neck. And the way that I do that is essentially by attaching the flat bar on the top, if you're using this style of truss rod, to some veneer. That way, when it's in the neck and you glue on the fretboard, the veneer actually glues to the bottom of this fretboard, and that prevents rattle. I have also done the method where you put the rod in and then have a filler strip that you epoxy on, and you put squeeze clamps so it squeezes it down the center, and that essentially preloads the rod, not preloads, but it squeezes the rod against each other. I actually don't like that method. I've had problems with the epoxy getting into places and messing up the function of the truss rod. So that's why I like this method. It allows me to do the glue up of the truss rod first, and then I can place everything in there. And when we glue the fretboard on, we'll be using Titebond, so I'm not worried about Titebond getting in anywhere, because Titebond doesn't stick to metal. So I'll just use some medium CA to go along the top of this truss rod. I'll just shift it around a little bit so I know the glue's spread evenly. And then I'll just hold it and wait for it to dry. When it's dry, we'll trim off the excess and put it in the neck. So now that this truss rod is dried and glued to this veneer, we're just going to use a razor blade to follow along the edge of the flat bar and cut off any excess that we don't want. And we may have to do some more trimming. This will just get it disconnected from the sheet. So seeing as we're about to glue on the fretboard, what I've done is I've taken some brass brads, small nails, and I've just hammered them in ever so slightly into the surface of the neck, and then clipped them off with my fret nippers right near the surface. And so what that does is it just leaves a little nub. And what I did was I took my fretboard, held it in place, and clamped down over where those nails are. So now on the fretboard I have little holes that register the placement of the fretboard. And that way when we do the glue up, my fretboard's not going to shift around on me. Alright, now that we've put our truss rod into the slot, we're ready to glue our fretboard on. We're going to be using a technique that uses what we call a strong back. It's essentially just an I-beam made out of 3/4 inch MDF. Basically it is what it looks like. But that provides a lot of rigidity. It's a very straight piece to glue onto, and this is going to act as our essentially a flat surface that we're going to be clamping to ensure that when we clamp, everything stays flat. We're also going to be using a caul to clamp the fretboard because our fretboard is already radiused, so we need to have a caul that works with that. Since forces travel at a 45-degree angle from where they're clamped, you can actually just make a triangle cutout in a piece of MDF, putting your fence on the opposite side it usually is in your table saw, setting to about 3 degrees and slicing from either direction to create this caul. Alright, for this we're just going to be using Titebond. For this first bit, I did not put on that much glue because I didn't want to get a lot of it near the truss rod slot in the center, but I will come back and add a little bit out towards the edges. Remember, Titebond does not glue to metal, so we're not really worried about that, but we still don't want to get a bunch of squeeze out into a situation where it could go into the slot, simply because even though it doesn't bond with metal, it does take up space and it can make a mechanical block of the truss rod if you get a bunch in a spot. It'd be pretty difficult to try and get that much Titebond in there that it would ruin the function of the truss rod, but why risk it? So when we put our fretboard on, we'll make sure that it's locked into those positive stops, those little brads that we put on, so that nothing shifts while we do the glue up. And then we will put it on the caul, on the strong back, the I-beam, and we will then start clamping. I usually start with just some squeeze clamps, and then I'll get everything in place, make sure that nothing is shifted, even though it shouldn't because of all the measures we've taken. But I'll do it with squeeze clamps first, and then once I'm happy with it, I'll come back and I'll switch out to some meatier clamps. One thing to mention, this neck is got the carve already roughed into it. I usually don't do that until after gluing on the fretboard. This neck is actually getting a new fretboard, and that's why it's already a little pre-carved. I didn't like what I had for the last one, so I pulled it off and did a new one. But usually I would clamp the neck before carving it. And as we go, if you start to get a lot of squeeze out, just go ahead and run a paper towel down the edge. The more squeeze out you get rid of now, the less work you'll have later. Plus, we don't want our neck being glued to our clamping caul. So now I'll remove my squeeze clamps because they're really not the best clamps for this. They're great for starting things out, but now I'll swap them out for better clamps. So once we've got all the clamps on, we're happy that everything is tight and there's no gaps on the edge of the fretboards. We're going to leave this clamped up like this for at least 24 hours. It's optimal just to leave it as long as you can, though. The more time that you let the water evaporate out of the glue, the less effect it could potentially have on the neck. The time has come to do the exact same thing that we did on the body and true up the binding on our fretboard that we put on earlier. It's done in the exact same manner that we did the binding, except that since our only flat surface is our fretboard, obviously if you did a pre-radiused board, you're going to have to flush the binding by hand with a scraper. But for one that doesn't have a radius in it yet, the only flat part on our neck is the fretboard. So instead of using a bearing on the bottom bit, we're going to have to use a template bit with the bearing on the top. And I just simply set this bit to follow the very topmost part of the neck. That way, if any glue nubbies have creeped down, hopefully the binding will not follow them, and obviously not cut correctly, but it'll follow the actual wood of the neck. The only spot that you want to be careful of is on the base side of the fingerboard, where you have this, we put the binding on the edge, on the end as well. You can't cut that part with the router, because the router is spinning in this direction. So if you bring that in here, you risk chipping out this piece. It's fine on the other side because the binding, the router is spinning into it, which is totally fine. But the part that the router is spinning out of, you can't do that little tiny section. So I'll stop about there. Beautiful results. Let's talk a little bit about headstock veneers. They're great because if you use ebony or other darker woods, it provides nice color contrast across the build. You can tie in a theme with the fretboard or something. And a lot of times you're not using a super dark wood material for the neck, so inlaying a logo can be a little problematic. And doing an ebony headplate or a darker wood headplate will help you with that. Another purpose is obviously to cover up our scarf joint, and this will cover up the face part of the scarf joint, whereas when we do a backstrap it will cover the back of that, but that is something that we will be doing later. There are several ways to do a head plate veneer. One way is to simply glue it onto the headstock and leave a little bit hanging over the brake, and then plane it flat and level with the fretboard surface. And for that way you obviously have to put this on before the fretboard goes on, or else you won't be able to plane that. The fretboard will get in the way. The other way that I like to do is a way that provides you with a nut slot that the nut actually kind of locks into. It's sandwiched between the end of your head plate veneer and the fretboard. And the way that I do this is I cut a matching angle into the edge of my head plate veneer before I glue it on, so that it is perpendicular to the fretboard surface. Here's a little jig that I made to do that. What it is it's simply two pieces of wood screwed together, both exactly the same size, with these two ends being parallel to another, so that when this end registers on the fence of my table saw, it sends this end through perfectly aligned with the blade tilted at 13 degrees. As you can see, 13 degrees off quarter, that is. And what this allows me to do is allows me to clamp the veneer in between these two pieces and just have a little tiny bit sticking out here, set my blade to 13 off quarter, and send it through the table saw. Now, there's a bunch of reasons why this is a good idea. One, because if you were to try to do that with such a thin piece of material without support on either side, you'd get a lot of chip out and you'd have a rough edge, which isn't something we want. The other reason why this is good is because it allows you to get that perfect angle to match your scarf joint, which would be very difficult to do with, say, a hand plane on something that's that thin. One last piece of advice for this jig. Before you put the veneer in, draw your center line and then draw your template outline on it so that you can put a line where you need the cut to go, so that when you put it in the jig you can still see where your perpendicular is, because I can't see the center line through my jig. One thing I wanted to talk about was head plate thickness if you're doing the lock-in nut style like this and not the plain flat onto the plane of the fingerboard method we talked about earlier. One reason why this is important is because, as you can see, this does reinforce the scarf joint. However, it doesn't reinforce the area where underneath the nut. This is important to keep in mind because the thicker your head plate becomes using this method, the thinner the actual neck section of the headstock becomes. And as mentioned earlier, the head plate isn't reinforcing this nut area, so actually the thicker the head plate becomes with this method, the weaker the nut area becomes and more prone it will be to cracking and breaking. The next step is to glue on your head plate veneer onto your neck. And as you can see here, I've put a stop block where the nut will be. This is for a neck that doesn't already have the fretboard on it. What you can do if you have a fretboard is just make a stop block that from about here back is a 1/4 inch shallower to match your fretboard, so that this can sit on the fretboard yet still create a stop for the headstock veneer. And since this has our cut in it, it butts up perfectly. Here is an example of what I've done for a block for something that already has a fretboard on it. The process we're going to go through is I've put a center line on here as well as on here, just to make sure that my cut is square and I can align things perfectly. And as you can, well, you probably can't see from that far away, but things line up perfectly as they should. So what I'm going to do is I'm going to put glue on it, tape it into place. That's a very important thing, because when you apply clamps, it is going to put pressure on things and try and move stuff around, especially with a slippery surface of glue. So I like to use tape to bind things in place before I put my clamps on. I often put tape like this to apply direction uphill. And I'll do the same with the initial clamp. You you can, if you've ever used these squeeze clamps, they pull towards the bar. So a lot of times I will start with a clamp like this just to get everything situated, if it'll clamp, so that it pulls ever so slightly that way before I start putting the bigger clamps on. But yeah, squeeze clamps are a good way to start. They're pretty quick to apply, they don't do any damage, and they're easy to get off, so if something does go wrong, like something gets out of line, you can fix it. And I'm going to go ahead and apply the rest of the clamps. Alright, here's what it looks like when you're done, and just for safe measure, I remove the stop block after everything is clamped in place and I know it's not going to move. That way I don't risk gluing my stop block to my neck. It's now time to talk about thicknessing the headstock so that we can apply our back strap to cover the back of the scarf joint. Now what I have here is I have a piece of plywood that I have thicknessed to be a 1/16 of an inch thinner at the nut end than it is at the tip. The reason I do this is because I like to do a 5/8 inch headstock near the nut to keep things thicker, but tapered down a 1/16 of an inch. It gives an elegant look, also gets rid of some of the weight you don't need down here to make headstock slightly less neck heavy. But it's a thing that a couple luthiers do that I've picked up, and I seem to like the look of it and the theory behind it. You don't have to do that. Headstocks can range anywhere from about 5/8, a little more, to all the way down to 1/2 an inch. I suggest measuring some of the headstocks that you have around the house to see what you like. So what we're going to be doing is, you can see there's a line down the side of my neck, and this follows where the neck carve is going to go. In this next case, 0.8 inches at the 1st fret to 0.9 inches at the 11th fret. And what this is going to do, and I'm putting this on the treble side of the neck, what this is going to do is when we start sanding, I'm going to be able to see where the neck is, and I'm going to sand all the way down the headstock until I hit a little bit past that line. The further past this line you go, all the way up to past it by the thickness of your backstrap, the farther this backstrap is going to extend into the neck, so you'll see it go further down the neck. This is the setup I'll be using. It's my spindle sander set up with the largest drum possible, and I've set a fence up to have this plate follow so that I can accurately thickness the headstock, and I'll be taking it down in several passes to ensure a smooth surface, as well as to not overwork the drum and get it heated or whatnot. And here's what it looks like when it is done. Here you can see what I'm talking about, where I go a little bit beyond my line so that the headstock backstrap comes into the neck a little bit. And we'll see what that looks like when you watch the video on carving the neck. Alright, as you can see, I have smoothed out this area where the backstrap is going to go. And I did this because even though the spindle drum leaves a pretty decent surface, it's not perfect, and I want this to be a nice gap. So I have sanded this by hand. Now over here we have the back strap, and if you're using a book matched piece like this is actually the face. If you're using a book matched piece like this, I either suggest one, gluing it up with super glue because that's more heat resistant than Titebond, or if you use Titebond, put some tape across the joint stretched to try and pull the joint together. So if for some reason you do overheat it when bending, the tape will keep the joint tight. Alright, for this procedure it's pretty similar to what we did for the wood binding earlier. At this thickness, which in my case is 40 thousandths, that's what I like to use for a backstrap, 40 to 50 thousandths. A lot of woods don't actually need any water to be bent. However, just in case I'm working with a difficult wood, I do keep some water around just in case. And just slow and steady wins the race. And you can see that it's starting to bend. We'll come back when I'm done with the bend and talk about glue up. Alright, and here you can see the finished bend. Try and get as close as possible, but as you can see, a little tiny bit. I mean, that looks bigger in the camera view. It's really only about a 36th of an inch. And when I press down, the clamps will get rid of that. Try and not leave too much of a gap, because you don't want any unintentional forces on your neck. And although this is a thin piece of wood, the amount of pressure that forcing this down when gluing will apply to the neck is minimal. I still don't like to have unnecessary stresses in my woods and my builds. Alright, and here you can see the backstrap being glued up. Since the headplate's already on, I have a plywood caul on the front to protect the headplate from clamping marks. And I have another caul on the back that I made with a radius equal to that of the drum I used on the spindle sander, so that it will keep pressure on the curved up area of the backstrap. The way that I built this caul is important. It's softwood, which is slightly pliable, as well as a thin layer of cork glued to it. And the reason I use cork is twofold. One, it will squish a bit so that when you clamp, if there's any discrepancy between the caul shape and the headstock shape, the cork will still allow you to clamp accurately and squish down. Secondly, if any of the glue from squeeze out does get onto your caul, it won't glue the caul to the backstrap because of the fact that the cork is quite weak and will just break off of the caul instead of being stuck to the backstrap. One important thing to notice is that once again I used blue tape to keep everything in place while I did the glue up. One last thing I want to mention about clamping up headplates and backstraps is if you are using a Titebond glue or similar, like I prefer to use for this application, you are introducing a lot of moisture to what is actually, in the grand scheme of things, a relatively thin piece of wood. And this is going to make it want to warp and cup, because the moisture introduced, let's say you're gluing a headplate on this side, is going to expand these cells, while up at the top here it's not going to. So it's going to make it want to cup in a U shape like this. So anytime I do any headplate or backstrap gluing up, I keep it clamped in this exact way for at least overnight. I usually like to leave them 24 hours if I have a choice. And then for another while, I keep them clamped to a flat surface. I know this is a little overkill, but I don't like to risk it. You've put so much work into the neck at this point, it would be a shame to have it cup and become useless simply because of a veneering. Alright, now that we have the back strap on if you're doing one, and the headplate on if you're doing one, I have remarked where my headstock template goes, and we are going to cut that out to shape. One thing to keep in mind, because of the angle on your headstocks, you're going to need a riser in order to hold the headplate up and flat. You don't want to keep it onto the table, because when you get close to the blade, you'll see that it pushes things up and it's no longer a 90-degree cut, and you may go inside your template by accident. So we're going to be using a riser plate just as such. Once again, the closer you cut to the line from your template without going inside of it, the less work your router will do and the less chance of tear out you will have. it doesn't get snagged on things later. Now that we've cut the headstock to shape and left a tiny bit extra, we're going to route it using a template. As before, I've used double stick tape underneath the template, but also, since I know exactly where my tuners are going to go every time, I've also countersunk some screws, and they go in just a tiny bit into the headstock, not even 1/8 of an inch, just to keep things exactly where I want them. Once again, just like any of our other routing operations, we're going to start at the peaks and work down, and then go into them to help prevent tear out, chip out. Before we can move on to the next section, we may need to access our truss rod. And since we've put a head plate on our headstock, that may be a problem, as you can see. Therefore, we're going to have to cut an access route for the truss rod. What I've done is I've created this jig that has a 5/8 inch gap in it with a stop. And I put the center line on the bottom so that I can match it up with the center line of the neck. Now, I've also put a 5/8 inch collar in my router bit and a 1/2 inch core box bit that will be making the actual rounded route. Essentially what we're going to do is we're going to have the 5/8 inch collar follow the 5/8 inch gap in the template and plunge down in. Now, as for how deep, this will be something that I'll have to show you in the results, as it's hard to explain. I recommend taking multiple passes and going a little bit deeper each time until you get a feel. Also, it's important to know how far your truss rod sticks out, as routing into the end of the truss rod is not only going to ruin your bit, but may also ruin your truss rod that is now stationed inside the neck. Let's talk tools that you're going to need for your neck carving. As you can see here, I have a number of files as well as what is called a Sureform rasp. The Sureform rasp is a good tool for hogging out a lot of material. As you can see, it's like a giant cheese grater, and they are quite cheap, so it is a good option. However, it doesn't leave as nice a surface as a hand-cut rasp. These are often called RU style rasps. I have the Nicholson 49. That is my roughest rasp, and then I have a number 3 and a number 4 from Herdem Tools, a German company, and these are the finer rasps. As you can see, the teeth get finer as you go to the left. I like these over the Sureform rasp because this rough Nicholson 49 will take out material about as fast as the Sureform rasp will, but it will leave a finer surface that's going to be less work for me later down the road. You're also going to want to build a jig such as this. What I've done is I've done a 13-degree angle onto a 2x4 section and then screwed to plywood so that I have an area to clamp it down. But the headstock will rest on here and is thus covered in cork to protect it. And then the base is a softwood so that it is less likely to mar any fretboard surfaces. However, you could always put cork on this as well if you were worried about it. I then also measured the lengths of different necks that I make and put an area here where I can clamp on the heel. The reason you're going to want a jig like this, as you'll see when we carve the neck, is your tools will often be at a downward angle, and you want the neck raised above a surface so that you have ample access to carve. As you can see, I've marked out where the neck connects to my body, because this is a point that we do not want to carve past for obvious reasons. And that is often a give and take between fret access and where you would like the bridge to be positioned on the body. I usually find it comfortable to have 2 frets inside the horn of the body. So I'll have 2 frets that I need to access after hitting my hand on the edge, and that usually seems to be comfortable. And I design my bodies based around this so that I have a nice aesthetic bridge location. The way I like to carve my necks is by creating a rough out of the profile in 2 spots. So I've already gone ahead and I've done the area around the first fret in the nut. And what we're about to do is do the same thing, rough out the profile around the 12th fret, which is usually a good spot to do. And then we're going to connect the 2 together using a spoke shave. Obviously the same techniques that we'll see when carving out these roughed out areas could be used to just do the whole neck in that fashion, but I find just doing the 2 and connecting them with a spoke shave is a little faster. And it's easier to just get a straight flat area. So all I'm going to do is I need to have a couple marks. Obviously I need to know where that 12th fret spot is, and that's where I'm going to be doing my carving. I've also marked out where the body will hit the neck on both sides. So here's the upper bout, here's the lower bout, and I've kind of roughed out where the body will sit. The reason I do this is because obviously I don't want to go behind that spot, or else I mar the surface where I'm going to be connecting the neck to the body. As you're carving, it's kind of hard to avoid this area if you're just kind of really working at it. You may just slip and hit, and then that's it. There's not much you can do to fix that. You can bring your heel down and try and get around any nicks that you did, but a good way to solve that problem that I've found is I'll go ahead and I will about 1/4 of an inch to a 1/2 inch out from where the body is. I will go ahead and I will just make like a channel. The reason this is helpful is because with this channel here, if later when I'm doing stuff here, if I go this way, it'll stop at that channel. It won't go into that area where I don't want to hit it. And just to show you, this is the channel I'm talking about. And it's just a little bit out from where the neck is. And that, even just that little bit amount there, that's enough. Alright, so I've just kind of knocked off the edge a little bit. I'm using this Sureform rasp to get rid of some of the bulk. And then I'm going to go to some RU style cabinet makers, pattern makers rasps to do the rest. Alright, so I've gotten rid of the bulk all the way up to that channel that we did. As you can see, I'm not too concerned with how the heel is at this point. All I'm concerned with now is doing the profile at the 12th, connecting the 2. I will deal with this heel transition area last, and generally I will deal with that after the neck has been routed into the body and I can see exactly where everything is sitting, and then I will finalize my heel. Right now we're just concerned about 12th to 1st. Alright, so I'm now going to go and use a pattern maker style rasp. Fairly aggressive one to start, and I'm going to use a flat area. I'm going to try and keep things parallel this way to the neck so I have a nice flat area. And see, you can kind of see this mark here is angled down, so obviously I'm pushing too much pressure on this end. So I need to, like I said, keep things parallel to the fretboard. There we go, that's a little better. Other side's good. I'm just going to connect these 2 diagonal areas so that I have pretty much a channel that I'm working in. can see, I'm literally creating a channel. If you're new to net carving, you should check frequently against templates. I've got a bunch of different ones here. I'll start checking a little later because I kind of know where I'm going with this. But if you're new to it, check often. Don't want to screw up. You can't put wood back. You can always take more off. And plus, with this rough rasp, we're not trying to get too close to our final carve. Right now, we're just trying to rough out, get the bulk out of the way. We'll go to finer rasps to finalize the shape. Since these are tapered, it may start to bind as you get a little further along. So what I'll do is I'll just come in and I'll knock the edges and kind of bring them down into this channel I'm making. And I'll bring that all the way down until it's flush here, so that way it's no longer binding when it hits the wide spots. I'm now going to switch to a lighter, a less aggressive file. I'm at about 1/8 of an inch thicker than I'll end up with. Obviously down here at the sides, even if I'm 1/8 of an inch thicker here, you can't bring that in 1/8 of an inch. So be very careful when you get down towards the fretboard because there's less play there that you can sand out scratches from later, etc. Because it's not just affecting thickness down there. If you don't pay attention, you can also affect the width of your neck if you get too aggressive there. So I'm just going to keep going like I did before, this time with my less aggressive file. All the while, I am checking with templates to see how I'm doing. What I'm doing when I check these templates is I'm seeing where the gaps are. I'm seeing where it hits. So it's hitting right here on that side. So that means that's the high part, as well as a little bit over here. So it's not quite rounded enough. It's too much of a D shape instead of a C shape right now. So I'm going to hit these two spots, and that will bring my template down a bit more onto it. The ultimate goal is to have the template hit all the spots equally. That means you're obviously matching the carve that you're looking for. I'm also watching the thickness as I go as well. So this is getting pretty good. And I am at about a little under 1/8 of an inch. I'm about 0.1 from where I want to end up in the end. So I'm going to keep going. I'm at about a 1/16 of an inch over thickness. I've got a fairly good match to my template. It's not perfect, but good enough for this stage. We're going to now start connecting these 2 points, the 2 carved areas. And to do that, we're going to use a jig. This is my net carving jig. It's just a 13-degree angle with some cork. It's got spots along that I can get a caliper in and check thicknesses if I need to. With this new technique that I'm using, I don't generally have to do that much. But if you do the all carve technique, where you just kind of rasp out the whole thing instead of doing the 2 areas and connecting them, those can be quite helpful. So I'm just going to put this in here, and the neck clamps onto this jig. What you want to make sure is that your neck is sitting on the jig flat. You're not introducing any bow because you're trying to carve a flat carve here, so you don't want to introduce a lot of bow. I use what's called a 0 angle spoke shave. So as you can see, the knife is actually at a 0 angle with the foot that you use to register onto the workpiece. This is just a personal preference. Any spoke shave will work. And literally we're just going to pull along, connecting the 2 sections. This is also why it's nice to have that heel kind of brought down, because if not, this spoke shave is wider than that channel is. So if I hadn't brought that heel down, I couldn't get in there and it'd be hitting and be annoying and stuff. So, and I'm just literally going to do this until I get the two sections almost connected perfectly to where this whole block in the center here that's still bulky is flush with both. While I do that, obviously the first fret area is a thinner section of the neck than the heel area, the 12th fret area that we just carved. So what I may do sometimes is kind of just do a half and then a 3/4 and then a full pull, because that's going to take off more from this end than it will that end, and I'm just going to slowly build in that taper. Or you could pretty much just bring it almost all the way down, and then you'll be able to see, like, this is flush, this still has a 1/16 of an inch, and you can see where to put it. All personal preference. We're done connecting the two areas. This doesn't guarantee that you have a flat surface all the way between the two. Obviously, even with the spoke shape, you can make mistakes. So we are still about a 1/16 of an inch thicker than we want to be in all these areas, and that's going to give us the ability to take a fine file now, or rasp, sorry, and we're going to go ahead and we're going to finalize this neck next. We're now going to switch to the finest of the rasps that I use, and then after that we will switch to a nice fine file instead of a rasp. Once again, I'm just doing the same stuff that I did before in the two areas that we started out carving, except now I'm just using light and angle to look at stuff, figure out where high spots are, low spots are. I'm going to try and get those relatively close with the rasp and file, consistently checking the thickness as well as against my templates. And then we're going to come back and sand when things are a little closer. And we'll be using some sanding techniques that will help us get things nice and curved and flat and parallel and all that. Except for this one high spot that I drew out and I'm dealing with now, we are ready to go and start our sanding steps. Nice. Alright, for the sanding steps, we're going to be using a number of different tools here. One of them is going to be the 120 grit duct tape strip. So basically it's just duct tape with some sandpaper taped to it. So this is our abrasive side. This gives it the support it needs. And also I just put little handles on here. We're going to be using this to do stuff like that. The other thing we're going to use is a flat block with a low grip paper. Here I'm using 120, but if you got a lot of work to do, you could use something even more aggressive than that. And what we're going to do is this is going to help us get flat across the whole entire neck. So any dips, this block is going to help fix those. So we're going to use the block first, and then we're going to perfect our round. So by standing lengthwise like this, it's getting rid of any high spots. It's bringing everything down even. The block is doing that. As always, you can look at your profile, use some light. As you rotate around, you should see equal parts of the neck as you look. So it'll help you tell where you may have high spots, low spots. Alright, so we completed our block sanding to make sure everything's flat. We've been using the light to check for dips. And now we're going to go ahead and make everything nice and round. It'll cut any highs or facets that we've sanded or carved in, all that sort of stuff. What I'm not doing is I'm not just going over it and pulling like this. I'm actually using it to shape a little bit. So I'm only really doing half of a neck at a time, even though I could do like this. I find it's better to. Also, our thicknesses are pretty accurate at this point, so I don't want to be doing a lot of pressure on the top of the neck where it'll affect thickness. I'm really just trying to round everything. So not a lot of pressure on the top of the neck, you're kind of just rounding the sides. Actually, now that we're pretty close to where we want things, this is also a good time for me to get out the rasp again, and I'm going to finalize the transition from the neck up into the sides of the headstock here. So, be careful because I did a diamond on this one. I'm just going to This is about where I stop at this point in the process. Since I don't know exactly where my heel will sit because I haven't routed the neck yet, I just have a general idea. I'm not going to finalize that just yet, but I am going to get everything smooth and where I like it in all the other sections. So as you can see, nice transition into the volute. Everything is nice and smooth, rounded, and this is where I'll leave it. So this is how I finalize the radiuses on my necks. I'm going to talk a little about the system. As we saw earlier, I rough out my radiuses with a router, but you obviously can't route when you have a lot of inlay work done. And either way, the routing is going to need some cleaning up with a nice radius sanding beam anyways. So this is a nice way of doing it. Basically all it is it's a radius sanding beam. You can buy aluminum ones. I had this one made by a friend of mine. And it's got 4 radiuses, one on each side. But the nice 18-inch aluminum ones are really nice. I like ones that are almost or longer than the fretboard that you're going to be sanding, simply because it's going to make a nicer, more even, flat radius. The reason for that is the greater the fretboard length is than the sanding beam, when you go back and forth, it's going to cut more in the sections that it hits twice than in the sections that it only hits once. So that's why we want a nice long sanding beam. This can be done with the shorter 6-inch, 8-inch beams that a lot of people sell, but I find that this is a better way. You have to check less. It's a more carefree way of doing it. As you'll see, I've just got some sandpaper stuck here. I'll do 120, 220, 320, 400 generally before I fret. And then these blocks are just to keep it from skewing as you're sanding. So imagine if you accidentally skewed a little bit to the side here, because of the radius, that would have made it so that you would have sanded more here and more here and less here and less there. So that would have given you a skewed radius. So your center line may have still been flat when you check it with the beam, but out at the edges you would have had areas that weren't perfectly flat. So although this has a little play side to side, it's enough that it keeps my radius straight. If you're really good at this, you can do it by hand too without these little blocks, but I just like it as extra safety. And literally I'll just hold onto the blocks and I'll sand. Another thing to keep in mind that I'm doing is I am marking the edges as well as the center, and then at one end, the center, and the other end, just to check where I may have spots still left to sand. Now that we're done sanding up to whatever grit we want our final grit to be, there's a lot of considerations when choosing the final grit that you need to go up to. For instance, if I'm doing a maple fretboard, I know that that maple fretboard is going to need to be finished, and depending on the finish that I'm using, it may or may not stick to really high grade or really high rated sandpaper like 800, 1200, etc. So maple fretboards I usually sand to the same grit that I'm sanding my body on because they get a finish. Rosewoods, other hardwoods like pink ivory, Bacody, basically your rosewood standard fare kind of stuff, I'm doing up to, depending on my mood, about 420 or 600. The reason I'm not going up to one of those really mirror gloss finishes on the bare wood, such as like 1500 or even up higher to 3200, what some people do. I've got two reasons that I don't do that. The first reason is we've still got to fret this thing, we've still got to do all the fret work, etc. I've found that by the time I'm done with all that, I've probably put nicks and little tiny dings and scratches in there anyways, that are going to be about at the 420, 600 grit range. So there's really no point in going up beyond those ranges until after I'm really ready to be done with everything and the work is all finished. Another reason that I don't go any higher than that is I actually don't like the look of those really mirrory fretboards. So I generally go up to about 600, fret everything, do my fret level dressing, all that work, and then I'll come in with some fine synthetic steel wool. And I actually like the look of a slightly matte steel wooled fretboard. It's equivalent to Quado steel wool. That's how I like my fretboards to look, so that's another reason I don't really go that high. One thing you will notice, especially if you have binding on your fretboard, is that you've got junk now in your fret slots from all that sanding work. So what we're going to do is we're going to come in, take our razor blade, our X-Acto knife, and basically you got to get all this stuff out. And it takes a couple passes per slot. And also, you want to make sure that you get up into the end of that slot and get things out of the corners. That's where stuff really likes to sit. There's one final piece of prep we need to do to the fret slots before we can actually go ahead and fret them. And this is just putting a slight bevel edge on each of the fret slots. We're going to do that with just a tiny triangle file. You can buy them for dirt cheap in these packs. I use them a lot for inlay stuff as well, from your standard big box store. Basically, the reasons we're doing this are twofold. It actually helps me push frets into harder woods, like your ebonies, the harder rosewoods, stranger ones like this pink ivory, Bacote. Having that bevel actually helps the fret line up when you're pressing it and go in easier. And the second, but in my opinion more important role here is that by beveling this edge, even ever so slightly only, that's going to make it so that you're cutting that end grain a little bit, so it's less likely to chip out if anyone ever has to do a refret on one of your guitars. Because when you pull the frets out, those tangs which are eating into the wood may want to chip it out. With that bevel, it's a lot more difficult for it to do that. And really, you hear people refer to this as a micro bevel quite a bit, because it truly is a micro bevel. That's enough. You can barely see it with your eye. Like I said, I just went across it kind of once, moving a little bit like that, and then I went back, moving back and forth a little bit, and really that's all the bevel it needs. One last thing I want to mention about the beveling of your fret slots. It also helps to prevent chipping on shell pieces or any inlay material really when you press the frets in as well. So I'll actually, right where the pearl crosses a fret line, I'll actually go ahead and put in a bigger bevel than I normally would. Another option for that, if you don't find that that works for you, if you're continuing to crack stuff, and that sometimes will happen if there's air pockets underneath the inlay, like your pocket wasn't perfectly flat, etc. Other options are you can actually file off some of the teeth on the tang where it crosses the pearl. That helps as well, or at least bring them down a bit. And another thing you can do is you can actually take this triangle file and file out the whole section of the tang if you're really worried. Next, we're going to prepare for fretting. This is what's called a fret bender. It pre-bends your fret wire into a particular radius before you press the frets in. You do it in long 2-foot sections. Basically, it's just a couple of washers, one small washer surrounded by 2 larger washers, and then 2 sliding glass door wheels. And basically on the back, one of these sliding glass door wheels is adjustable along a distance so that you can change the radius by adjusting where this wheel sits. I built this one, but they're readily available for pretty cheap now. This one's been dying pretty quick, So I'm probably going to buy a real one that's made out of something a little more sturdy than melamine, MDF, and has some nicer components than this, but I mean, it works. Essentially, the gist of it is you take one of your sticks of fret wire. Sometimes if your radius is pretty aggressive, 12-inch, 16-inch, they don't seem to have this problem as much. But when you get into the fender style radiuses of 7-8 inch range, you start to have to kink the front tip so that it already has a little area that it can pass through, because that front doesn't really want to bend that easily. But for this 12-inch radius that I'll be doing right now, I find that I can push fairly close here. If you push way back here, you'll bend your fret wire in all sorts of directions and it'll be ruined. But I found I can push here and rotate this wheel a bit, and that helps get it started. Sometimes you will have to do that little kink though, but let's see if I can get this one. There we go, see? So basically what that did is that just started that first little area there, as you can see. So now what I'll do is I'll go through and I'll just simply push the rest. And you end up with a coil of fret wire. Generally, what we're looking for in a radius is not to be exactly the same as what we have on our build, but actually a little more radiused. As you can see, there's some space underneath the center there because the fret wire has a slightly greater radius than my fretboard. The reason for this is when you press the frets in, you're going to have the tangs, which is the grippy part there, the kind of like teeth. You want those to seat down in really well, and you also want them to spread out a little bit as they seat so they kind of grip into the wood. And having an over radius fret wire does that, so when you press it goes down and out a little bit. Another great reason for over radius fret wire is if you have binding on your fretboard like I do here, the tang obviously isn't going all the way out to the edge. So by being over radiused, when you press it in, there's down pressure at the edges of the fretboard, and that's going to help seat that better at the edge. Now that you have all your fret wire bent to the radius that you need, it's time to take one of the pieces, and as you'll see, there's a slight kink. You can kind of see it there, and also you can kind of see it. It's not as much on the tail end when it comes out of the bender, but the front part definitely has a little kink in it. What I need to do is obviously get rid of that. We don't want to use that kinked part. Then I'm simply going to go around and start cutting off pieces of fret wire that are the correct distance for the fretboard width of that fret. Obviously, since all of these frets are a different distance or a different length, you have to measure out each one. I find it helpful to have a little jig like I have down here. It's just got a bunch of holes in it, 24 in case I want to do 24 frets on a guitar. Right now the one I'm doing is only 22, but basically I'll take these fret nippers, I'll go up almost to the edge of the fretboard, cut off the extra, and now that is fret number 1. And I'll go along in this fashion, doing all the different frets until I have enough for the whole guitar. Mind you, this isn't a necessary step if you don't have binding on your fretboard, but I'm going to explain why it's still a good one. The fret tang goes all the way to the edge of the fret wire. If you have binding on your fretboard, obviously it can't be pressed in there, so you have to remove that area of tang. We do this with a tool that StewMax sells. They're the only ones that I've found it from, but luckily I like the way that they made it. So, and basically the fret just goes in the tool and you pop down and it removes that for you. You can also obviously clamp it to something and file it with a triangle file or whatever file you choose. I've done that before. It takes forever, but it does work. The other reason, even if you don't have binding on your fretboard, that you would still want to do this is, have you ever played a guitar where as you're playing down the fretboard, you can feel the frets coming off a little bit. That's because wood will shrink and expand at a faster rate given a constant humidity change than will metal. And so in a really dry, cold climate, the neck may shrink, and it may be minute amounts of shrinkage, but it's enough to stick that fret over the edge a tiny bit and hit fingers. The great thing about taking the tang off is, one, you don't see it from the side, but also, if that happens on a guitar, you can simply come in and re-bevel the edge of the frets, and that will pull all those frets in nice and tight. Whereas if the tang was sticking out as well as the edge of the fret, then you'd have to go in on the actual side of the neck and sand that flush. And on a finished guitar, this neck's going to have finish on it. So any sanding you can avoid in a finished area is going to be great. So regardless of whether you have binding, I still recommend pulling the tangs off, but it's not a requirement. I'm just going to go through and do this for all the tangs, measure them up on the board to make sure that they clear the binding. Now we're ready to actually start pressing frets in. One thing that a lot of people will do is they'll actually put some glue in the fret slot right before they pull the lever and press it in or hammer it in. They'll generally use a PVA glue or hide glue, or in this case fish glue. The reason these glues are acceptable for this purpose is none of those glues actually will stick to metal that well. So all it's doing is it's getting in the fret slot, it's filling up spaces, and then when it hardens, it's hardening around the tang, so it does create a mechanical bond, but there's no chemical bond, so you can still pull the frets. However, in my experience, I've found that it doesn't really need it, so I don't generally do it. But if you're worried about it, that's fine. I find that it makes it a little bit more of a pain for the person that comes behind you and has to do a refret on your guitar. But that's just my personal opinion. I haven't found the need to fill the glue slots. So all we're going to do to start the fret process is we're going to take our fret ready, and we're going to seat it so where it's finally going to go. So a little overhang on each side. The tang placed in the right area, and then I'm just going to use the plastic orange end of this hammer. Sorry, that one was just sitting there. And I'm just going to hammer in just the edges, and then we're going to come over here in a minute and press the frets. I am, however, going to show y'all how it would be like to actually do all the frets without a press, since we're here already. This is my press. This is how I prefer to do the frets, but if you do just have a hammer, you can hammer frets in alone. So let me line up where this needs to go. Alright. And then once again I'm just going to do the edges with my trusty plastic part, and then I'm actually going to switch to the metal part for the actual pressing of this fret, or hammering this fret. I'm going to go from one side to the other and then back. And I'm going to check it, and as you can see, that fret has seated. So now that I've hammered the sides in on a couple of them, and this is just to kind of keep them from moving. It registers them, so when I press, they're going straight in. Either way, now that that's done, I'm going to come over to my arbor press. This is a 1/2 ton arbor press. I'm going to use a caul underneath the neck, and this is a tool that, in this guitar's case, has a 12-inch radius that allows me to press the frets in. So basically, I'm just going to support underneath the neck. I'm going to make sure that the fret is on this caul. I don't want to ding my fretboard when I press. And then I'm just going to press it in. And once again, we have a seated fret. So you might ask, if it was so easy to hammer the frets in, but also relatively easy to press the frets in, why spend all this money on these extra tools like the press, the call here. There's a couple reasons why I find pressing frets is better than hammering frets. So first and foremost, it is a smoother, more even push with a arbor press than it is with a hammer. The hammer's kind of by definition a jarring tool, and so if I'm pressing over inlay material, it's really better for me to press the fret in delicately than it is to hammer it in. I'll have less chance of chipping that out. Another main reason I like pressing better is simply because the metal part of the hammer will leave tiny little hit marks on the fret, and that just leaves me a little more work to do later when I do the fret level. But both of them work really well, and having the skills to do both is really good, simply because if you start doing compound radius boards, you either have to buy a bunch of different call shapes, and none of them are going to be perfect for every fret, or you hammer them in. So it's a good skill to have. There's two more things we're going to do to the frets before we leave them alone for now. The first thing is, if you've ever had a guitar where while you're playing and you accidentally get the string off the edge and it gets caught underneath the fret, it's really annoying. So what we're going to do is we're just going to take some medium CA. Let me be very clear. Medium CA. Thin is a nightmare. I've had it wick all the way down the fret and had to manually with a razor blade scrape CA away from the fret. Not worth it. Please use medium. The thick is just a little too thick and it doesn't do the job properly, so medium. All we're going to do is we're going to come through and on the hangovers with the fretboard facing down, so if it does want to run at all, it doesn't run onto the fretboard. We're just going to come in and we're going to leave a little dot of medium CA right at the edge. Literally, like not even that much. All that's doing is it's sealing that connection between the fret and the fretboard so that nothing can get under there. And when we go trim the fret ends and we sand everything, you won't see it at all. So that's all we're going to do. You're going to do it for all frets, both sides, and then we'll come back and we will nip those fret ends off. So now that the super glue under the edges of the frets is dried, we're going to come in and we're going to nip the fret ends off. We're going to do this side to side, as you see here. Do not do it up down. You run the risk of pulling the fret up a bit and leaving a gap, disconnecting any of the super glue that you just did. So side to side, down both sides. It is time to go ahead and sand the edges of the frets so that they aren't so pointy. I also leave my side dot sanding until now just so I'm not sanding the edge of the fretboard twice. I can just kind of do it in one go. I'm going to use 120 grit. And my sanding block, I'm not going to use the cork face, I'm going to use the hard face simply because these are so sharp. I'm going to sand it just like I would sand any other thing. When you're off of the heel, do your best to try and stay flat. So what you're looking for to be done is no points on the fret from where the center of the nippers was. So a flat, dull edge on the fret that is flush with the edge. And also, you can kind of see it here on some of the frets that you can see still the super glue. So the super glue there, super glue there. You want to get the super glue off of the surface. That's your goal here. Once I have everything sort of to where I want it, I'll go ahead and switch to some 220 grit and just give this a nice final go at. Let's talk inlay design, because a fine inlay can really either make or break a guitar. And also the idea of having a running theme across a guitar is something that I seem to like. So putting a lot of planning into your inlays is always a good idea. And that first step of design comes in the form of tracing paper or you might know it as vellum. You can get this at most art supply stores. It's pretty cheap and comes in large packs that'll probably last you a decent while. I'm not a great drawer, so I usually take pictures or find images on the internet and go from there. However, if you're an artist, obviously drawing your own stuff can be very exciting too. And essentially what I'm using the tracing paper for, and you'll need this if you're your own drawer as well, is you end up with pieces like this. This is a tracing that I've done from a picture of a whale that I found, and it usually takes you several tries to get it perfect. So what I'll do is I will make a first tracing and then make subsequent tracings off the previous tracing until I'm happy. It usually takes me several tries to get it to where I'm absolutely happy with it. Also keeping in mind where your frets are so that you know where you can have pieces disconnect so that you don't have to use such large pieces of shell or wood or stone or whatever you are inlaying with. Once you're happy with your tracings, go ahead and tape them onto some white paper, and we're going to go ahead and make photocopies of the inlay designs, and you'll end up with something like this. Now, it's important when doing your tracings to use an extremely fine pencil. I use a number 11. It's extremely hard and leaves an extremely fine line. The reason behind this is when you are doing a complex inlay where pieces actually touch one another, the finer the line, the less likely you are to have gaps between your inlays when you cut them out. Now, for inlays where it's not any piece ever touching another one, it's just single pieces, solid lines are okay. Another thing to keep in mind is that inlays where multiple pieces touch one another, you're going to need multiple copies because you will be cutting around each of these pieces so that you can glue it onto your inlay material. And you're actually going to have to cut outside the line because when you start sawing them out with your jeweler saw, you're going to be cutting on the line. Now that means you're going to need as many copies as the maximum number of pieces any piece in your inlay touches another piece, i.e. up here, this piece touches two other pieces. So for this inlay, I would need at least 3 copies, providing I made no mistakes. Also to keep in mind, as you can see, all of my inlays are closed shapes. Any lines that simply end abruptly and don't make a full closed shape will have to be engraved and not inlaid. So this is something important to keep in mind. Alright, let's talk a little bit about the tools you're going to need for inlay work. First and foremost, you're going to need a Dremel device, or, well, a rotary tool of some kind. I happen to use Dremels. And you'll also need a precision router base for your rotary tool device. This one is from StuMac, and I'm pretty happy with the performance of it. The router bases you can buy from Dremel that work with Dremels are not precision. You need something with higher tolerances because inlay work is so fine and detailed. Next, you're going to need a bunch of bits to work with your Dremel. I keep a couple 1/8" bits so that I can hog out material on large inlays, some 1/16" bits for general inlay work, and a bunch of 32" bits. They break kind of easily for doing very fine detail work and the final edges to make your inlay perfect. And that is what you're going to need for cutting out the actual channels of the inlays. Before we get to that point, you're going to actually have to cut out the shell. And for that, you're going to need a jeweler saw, some blades. They come in all sorts of sizes. They go from like 3, 2, 1, 0, and then from 0 down they keep getting smaller, but they don't go into negative numbers. They go into 2, 0, 3, 0, 4, 0. I happen to like 2, 0 for most of my inlay work. It seems to work. And this is the base that I use for cutting my inlays on. And you'll see how that works and why I've got these little channels and the shapes like that when we cut out some inlays. And lastly, if you're planning on doing any engraving, you're going to need a graver. Keep it very sharp. And oh yeah, 2 more things. For the actual inlaying, you're going to need a X-Acto knife. I use number 11 blades. They seem to be a nice size. New sharp ones are a must because ebony can get pretty hard. And also chalk, just standard old chalk, and you'll see why in a little bit. Also, I'm going to talk about the choices of glues to work with inlays. Now you can go with standard super glue, and that's what I use most of the time, because then you can fit the pieces into your cavities and flood with CA if it's thin. Another way is to cut the channel for your inlay, fill it with some epoxy, and then put your inlay in. I prefer to put my inlay in first though, and I'll explain why in a little while when we actually get to inlaying. And also another thing that's handy to have is whenever you're working with ebony, keep some of the dust, because if you make a mistake in your routes on an ebony board, you can actually fill ebony dust in to the mistakes, and when the CA touches that, it'll actually become very similar looking to the ebony around it. This doesn't work as well for other woods. Rosewood, you can kind of get away with it sometimes with rosewood dust, but once you get into other woods like maple, koa, anything light, you better have your routes perfect, because any mistake will show and it will be obvious. Here is one of the inlays that I'll be showing you how to inlay with. Now, although this looks complicated, it is actually done in the cut out in the exact same manner that we cut out the logos earlier, except it just takes multiple pieces and you fit it together like a jigsaw. What I've done is I have tacked it down to the board with some CA just a tiny bit. You don't want to get it too stuck because these pieces are fragile. If they do get too stuck, you can always flood some acetone on the board to get the pieces off. I'm using super glue because I've run out of rubber cement, but I do prefer rubber cement. It's a little easier to get the pieces off with. So what we're going to do is, now that these cannot move, we're going to take our X-Acto blade and literally just go around, and this is called scribing. I'm just going to essentially cut a little bit, just a little bit, into the ebony. And what that's going to do is it's going to leave me a line, and I'm going to go ahead and do the rest of this, and when we come back you'll see why that line is important. Alright, as you can see, I've already taken off some of the pieces of this first whale. It was just so that I could get some stuff out of the way to help me scribe some other pieces. But essentially all I'm doing is just taking a razor blade, slipping it underneath, and pulling these off. And one important thing I haven't mentioned yet, as you can see here, is pieces that go together in the inlay, glue them up together before you actually do any scribing, because any slight change in the way that the pieces fit together after you've scribed onto your board or inlay surface will make a gap when you're done. Because let's say that they fit together ever so slightly left when you first glued them up, when you didn't glue them up and you glued them down, and then you glue them up and it shifts a little bit, well, that's going to be a different routing pattern. And so you'll end up with gaps, and you won't be happy with that. Also, this technique does not work with really thin pieces. You will snap them. So I do recommend getting some acetone and flooding it down the board to release really fragile pieces, such as the logo that we saw earlier, the little tail on my mu symbol. I won't do that with that. Alright, so as you can see, we have our scribed lines and some junk left from the super glue, but that's no big deal. All I'm going to do is take my chalk, scrape a bit on here, shaving it off. I'm going to rub it on, and what this is doing is it's going into those little cracks that we cut with the X-Acto knife, and it's highlighting our lines for us. So now we have a template to route to. Alright, so now we're actually ready to do some channel routing. Cavity routing it's also called. And what I need to do is I need to make sure that I'm routing to the correct depth. So all I'm doing is I'm taking a sample piece of my inlay, assuming my inlay is all the same thickness, because you can get shell in a number of thicknesses. Recon stone you have to usually thickness yourself, it comes really thick. But mine are all 1/16 of an inch. That's what I use for fretboard inlays, because 1/16 of an inch is thin enough to cut comfortably and have perfectly square edges. And it's thick enough so that when I radius a board, I know personally up to 12-inch radius it'll hold, even all the way, almost all the way across. I'm not sure about fender radiuses like 9 or 7.5 and stuff like that, because I don't actually use those radiuses. So you'll have to do some calculations or drawings yourself to figure that out. See what you can get away with. For flat inlays on headstocks and stuff, you can get away with buying cheaper, thinner shell at about 0.3, 0.4 they sell it at as well, but 0.03, 0.04 as well. But I use 0.06 for fretboard stuff. So yeah, I'm just putting the shell up to the bit and adjusting the height adjusters until it's the same. And then all we're going to do, turn it on, we're going to drop it in, route around. I'm actually going to stay away from the edges. That I'm going to leave for a finer bit, because this 1/8 inch bit that I'm using to hog out the big areas is pretty aggressive and doesn't always leave the cleanest cut. I'll come back in and do 1/16 of an inch to most of the edges, and in the really tight spots I'll do 32nd inch bits. One reason I'm showing you guys the routing on this big inlay instead of the small logo inlay is because the techniques are the same for this big one, except with this one I can also show you a lot of hogging out with a larger bit, which you'll never need for small things like my size logo at least. Alright, and here you can see the finished hogging with the 1/8 inch bit. This is pretty much about as close as I will get to my lines. If you need to apply more chalk, go ahead, no harm. Alright, I've set up my 1/16 inch bit to go to the exact same depth, using the same technique that we did before. And this time I will actually go up to my lines, and this is where the actual, some people describe with a point, like just an awl, and that puts a little line, but it doesn't put a cut in the wood. This is where I actually like the cut better, because, and I'm not going to be able to show you this, I'm sorry. Actually, let's see if this will zoom in, because let's hope you can see this as I go around. No, I don't think you're going to be able to. But what I'm looking for is, as I come up to this edge, I'm going to be going counterclockwise into the wood to cut it, and just shave it off as I come close to the edge. And once you hit this edge, you'll actually see that white start to feather off and disappear, and that's when you want to stop, because what it's doing is you've just cut into that little channel, and what that's going to do is it's going to leave you space for your inlay and a tiny blade's width of space for glue. And you actually want this, because fitting inlays in a perfect route is actually very difficult. Even with CNC machines, they leave a little extra to fit in and glue space, because glue lines actually are thicker than most people think. So I'm going to go ahead and do a little bit of this. And as you can see, it's very slow work. All I did there was this 1 fret's width of the bottom of this whale's chin. So it's slow work, but slow makes good. And as you can see, the white line is gone down there. That means we're good to go. I'll finish up the rest of this whale and use a 32nd inch bit where I need to, but technique is actually absolutely the same. One more thing to note is, as you make progress, test fit your pieces. As you can see, I thought I was done with this one, but there's a little space up here that's making it so the piece doesn't fit in. So I'm going to go back and I'm going to hit that with the router and test fit again. One of the bad things about test fitting, though, is that if you have a really tight cavity and you test fit your piece and it goes in and it's really tight, you may not be able to get that piece out again, which is fine if you're using the CA flood glue method, which I'll show you later. But if you're using an epoxy method, that can be bad, because you may break your piece getting it out. So be careful. If the piece doesn't want to go, don't force it. And there you have it. Our first piece fits. I do my inlays piece by piece. One more important technique is even a 32nd inch router bit won't give you a perfect point route. So for places that have some of that, such as the tip of here, you're actually going to take the X-Acto knife and I'm just going to cut. And ebony's quite hard, so it may be a little difficult, but that's why sharp blades are the best. And there you have it. I now have a point for the inlay to fit in. Alright, let's talk glue-up methods. As I mentioned before, there's really two ways to glue up inlays. One of them, like I said before, is to put the inlays in before and then spread super glue around. And the other way is to use epoxy and put the epoxy in first and then press the inlays in. Both methods have their pros and cons, and I'm going to explain when I like to use each of them. If I want an extremely tight line on somewhat softer wood, sometimes I'll use it on ebony as well, I will use the super glue method, because what this allows me to do is it allows me to make the cavity exact, like not even like the lines difference. And what I do is I take something stainless steel, because it does not flex at all, and I will actually put the inlay onto the cavity, put this over it, and then clamp it down. And what's happening is the steel is acting as a backing board and pushing the inlay in, and it will not crack the inlay because the steel does not give, so it doesn't allow the shell to warp anything from causing a crack. However, you're limited with this technique by the size of your biggest piece of stainless steel. That said, you can use the super glue technique without press fitting. I like the super glue technique better, personally, because I can put everything in, make sure everything fits, fill cracks with some ebony dust if need be, and then super glue when I know everything is ready to go. The times that I like to use the epoxy method is boards like this that are already radiused. I actually don't like setting up rails along the sides to keep my base
and now in
even,
the second picture,
because what I do with radius boards is, since I already know the curvature,
and its
for pieces like
that 1.72 inches into
well, for pieces like this, the body of the whale here, I'll actually angle the fin down from where the body is, so that I can keep a thicker inlay. And in order to do that, the base has to be able to follow the curvature of this board, but that can also lead to some inconsistencies in the depth. So because of that, I don't like air gaps behind my inlay pieces, because that can cause them to possibly crack down the road. So for this type of stuff, I do like the epoxy because it's more gap filling. One other thing to keep in mind is, as you can see, another reason to have all your pieces glued up beforehand, like all the pieces that will be touching each other in the inlay, is because we are going to be using ebony dust in our epoxy mix. And if you don't do that, you run the risk of having black lines between some of your connecting pieces, and that will just look like sloppy work. So keep that in mind. Glue up all your stuff beforehand. And I'm going to mix some epoxy and we'll come back. And this one we're going to do with the epoxy glue-up method, and my logos we're going to do with the press fit super glue method. Alright, so my epoxy and ebony dust mix is made. I use something called DevCon 2-ton. I use the 30-minute. It's plenty of open time. It dries hard, and the best thing about this epoxy that I found is its ratio is 1:1, and it's pretty lenient on that 1:1 ratio, so you don't have to measure it and weigh it and all that sort of junk. And literally all I'm doing is I'm taking some scrap, and I'm going to just start filling each cavity piece by piece with a little bit of epoxy and ebony dust mix. One more quick note: if you're going to be touching the epoxy, try and get some gloves. Prolonged exposure to epoxy can actually lead to sensitization, and if you like epoxy, that's not something you want. Alright, whale number 1 has all of its pieces input. We've got a little bit of epoxy left. So what I like to do is, I got a good amount of squeeze out, which is something I'm looking for. Squeeze out means that everything underneath is filled and your sides are all good. But with my extra epoxy, I do like to just go over the top of the inlay. And so just in case there are any little gaps that weren't filled by the squeeze out, this will fix that problem. And there's the epoxy glue-up method. After a quick rough sand, you can expect something like this. I'll have to re-slot it, obviously. As you can see, there's a little sanding left and a little bit here, but you get the idea. Alright, so as you can see, I've already put one of the inlays in. We are actually going to go ahead and I'm going to show you how to press fit inlays for the super glue method. Like I said before, you don't have to press fit them for the super glue method, but this does make a very tight inlay route. As you can see, the inlay does not press in on its own. It's relatively accurate. It's not 100% perfect, and that's actually what you want for this inlay glue-up method, because that will actually compress the fibers and give you a very tight pocket. But it has to be pretty dang close, because if it's not close enough, it won't press in. So it takes some getting used to. So all I'm literally going to do is I'm going to protect the back of my workpiece. I'm going to push the inlay so that it's not moving around. It's chilling on the pocket. And then I'm going to take my steel, put it above the inlay, and then I'm going to take a clamp, a relatively strong one. Actually, let me move this so I know exactly where it is. And then all I'm literally going to do is tighten this clamp down on this inlay piece. And you should see the steel move down. Tight. Make sure to protect your work pieces. I did. And there you go. Press fit inlays. Okay, now that the inlays are in place and inlaid, I'm going to take a bit of ebony dust that I just keep in a jar, because this is an ebony faceplate. I'm just going to put a little bit on there, and I'm going to push it into any voids, cracks, crevices, etc. that may be in the inlay. This is a relatively tight inlay, so there shouldn't be that much. That's why I didn't use that much. Alright, and now that you've got that filled and nice, just take a little super glue, you go ahead and flood all the way around and on top of your inlay. When the super glue's dry, we'll go ahead and level sand it, and it actually may need another coat depending. Super glue sometimes will leave little bubbles and whatnot, but you can pop those with a X-Acto knife and just go ahead and put more super glue in there. Sometimes if you do have voids, you'll have to redo the ebony dust as well. So the first finish we're going to learn about is the True Oil finish. It is this product. It goes on very thin, yet it is very, very easy to apply. That's why a lot of people like it. I'm going to be showing you the way to do a satin version of it, but it is possible to do a full gloss version with True Oil as well. Because True Oil goes on so thin, I like to have things really well sanded. You don't have much filler per se. Like when you spray a nitrocellulose finish, a little bit of that is going to fill any cracks or anything like, not cracks, any sanding scratches and whatnot, and it will actually help hide them. That's why we only go up to about 320 with those kind of finishes like nitrocellulose. But with something like True Oil, you don't have as much filling capacity. So I like to sand everything higher for a True Oil finish. Minimum 400. I like to go to 600. But we are actually going to also have to pour fill. So the difference between the sanding scratches and the pour filling, you might ask, is sanding scratches, you do need them level with the rest of the surface or else you'll see them. But the interesting thing about sanding scratches is that when you spray a finish on them and level, they'll actually disappear. Whereas when you go and do a pour fill, which we're about to do, this method, it would actually highlight the scratches because we're leaving little bits of the wood mixed with the True Oil as pour filler. So it's kind of pour highlighter, and so it would also technically be scratch highlighter. That's just another reason why for this method I like to go up a little higher than usual. Fairly simple. We're just going to take a sanding block, and I'm going to show you on this test piece because I've already done this on the guitar. But we're going to take a sanding block, some 600 grit paper, and some True Oil, and literally I'm just going to apply some of that True Oil to the wood, and just like any other sanding operation, we are going to sand with the grain. And what this is doing is, even though this is fairly fine sandpaper, you see it's got some schmutz that it's leaving. It's a mixture of that fine sanding dust and the True Oil, and that's actually going to go about filling those pores. So I would go over the whole entire body like this, and then I would actually let that go ahead and dry. A little bit, not fully. Once it's dried, I'm actually going to come back with some 600 again, but without the True Oil, and I would level sand everything flat just to make sure that there's nothing sitting above the surface. It's only in the pores. Keep in mind that you may need more than one application of this, but that will all depend on whether you can actually see if the pores are filled, and I'll generally just kind of hold it up to a light, and that's generally a good way to see if there's actually stuff in the pores. It's really hard to explain on video. You'll have to try it. But once we have filled, sanded with 600 again, it's good to go into the next step of the process of applying the coats. So let's talk about making your pad for the application of True Oil. It's going to require two things. I just take an old beat up t-shirt and I'll cut a little square out of it. Basically any lint-free cloth, and I'm going to make sure it's lint-free at the edges because sometimes cutting this is good stuff. And we're also going to use a little paper towel. And when I say little, I literally mean a little. So I'm just cut that in half, and then I'm going to cut this in half, so about a quarter of a sheet, and I'm just going to create a ball with it. And then that ball is going to go into the center of the cloth to make a little pad that you can hang on to, dip in True Oil, and then apply. The reason I do it like this is I used to do it with just paper towel, and I'd get little, no matter what you did, you'd get little tiny bits of paper here and there in your finish. So having a lint-free rag helps with that. But the bad part is with the drying oil, this thing's not really reusable, so you don't want to use anything like expensive. You don't want to make yourself a really nice one. So that's why I just use beat up paper, beat up shirt and a little paper towel, because everything's disposable here when I'm done, because drying oil, it's going to dry on it, this is going to remain hard, and pretty much I find that they're good for about one application. To apply the True Oil, I use a glove. It's really sticky stuff. To my knowledge, it's not dangerous, but it is kind of annoying when it gets on your hands. It's really, really sticky. I'm just going to take a little bit and apply it to my pad. And then I'm literally going to go around in circles, and I'm applying pressure. So by the time you are done with a coat, your arm should hurt a little bit. It's just like French polish. The reason for doing this is a lot of people follow the instructions on the back that says just to kind of smear it on there and whatnot, and I don't find that that works well. The reason I don't like that is a lot of people will follow the instructions on the True Oil bottle to a T. They'll just kind of wipe it on without any pressure or circular motion, just kind of a wipe on, wipe off sort of exercise. The reason I don't like that is because True Oil goes on extremely thin, no matter how you do it. It's just the nature of the beast. And I found that just wiping it on doesn't leave you a smooth enough surface, so you'll have to go back there and do a lot more level sanding than you will doing this French polish style. The problem with level sanding True Oil is, once again, it's very, very thin, so you don't get much leveling ability before you go through it. So I would prefer to just put it on nice, thin, but even at the start than to have to come back and mess with it later. So that is why we were painstakingly polishing it onto the guitar instead of just slathering on and wiping off. And I will do this exactly the same for all parts of the guitar: neck, back, top, sides, whatever. This is how I will go about it. And I'm going to put about 12 coats like this on total over a couple of days. And one thing I've found helps, if you look at angles and light and stuff, you'll be able to see where it's going on a little thick, or especially in areas like this where you can't really polish out. It's important to kind of come in there and sop up a little bit of that extra if there's extra sitting around. One thing that I have found that you should probably look out for is on very sharp edges, so like where the side of the headstock meets the top of the headstock. I'm going to come in here and I'm going to do the sides first, because I can't really do a swirly motion, so I'm just kind of applying pressure as I go back and forth. But what that's doing is it's squeezing oil out of my pad, and not only depositing on the side, but it's also depositing it on the face of the headstock. So right on the edges, there's now a glob of True Oil. And that's why I do the sides before I do the top and back of very sharp angles like that. Because now I'm going to go in and I'm going to polish the top, which is going to make sure that I don't have these globs on the side. Although True Oil does go on thin, when you get those globs, they will remain relatively globs. They'll get smaller as it dries, but you will not have a flat finish, and they are going to be difficult to get out easily and cleanly, in my experience. Your final step with each coat is to take apart your pad, and what we're going to do is we're actually going to leave it to dry fully unfolded. So one interesting thing about drying oils, I'm going to see if I can do this with one hand. One interesting thing about drying oils is that they will actually heat up as they dry, and so if you keep things really balled up and folded and compacted, it'll actually build a decent amount of heat, and although rare, things have been known to spontaneously combust with drying oils. So I'll just leave them there overnight, and they'll get hard, and I'll just throw them away. Since I'm going to be doing a satin True Oil finish on this guitar, my last stage is to take some it's synthetic steel wool. It comes in a couple different grits. So I use the gray grit, but they also have an extra fine, I think it's called fine. They also have an extra fine white, and then they also have a red and a green, which get coarser, so medium and coarse. But I find that the gray is good for my purposes. It's relatively equivalent to Quad-O steel wool. And I'm going to show you what I'm trying to get rid of. So the process that we've been doing, I don't know if you can see this, I'm going to try and get it so the light catches a little. See how it's got almost like some swirl pattern in the finish? So that's left by obviously the swirling action we've done during the process. what I'm going to do is I'm just going to take my steel wool. I'm going to pick a good spot to show you guys. And I'm just going to dull this out, and it's also going to flatten it as I go. And since the true oil goes on fairly thin, as you'll see, it fairly quickly, see, there you have swirl and no swirl. So this whole area now that I just hit is swirl free, looks nice and uniformly matte. If you wanted to keep a high gloss finish, I haven't done it, but everything tells me you should probably be able to do a very high grit level sand. Like I said, true oil goes on very thin. This Quado steel wool equivalent, synthetic steel wool, is flattening. So very, very high grit level sand and then buff if you want to buff out your true oil finishes, I'd imagine. But I've only ever done satin, and that's how I do them. I'm getting to this stage after about 12 coats. So just to go through everything again, we did the pour fill, and then I did 12 coats, no more than 3 a day, with 2 hours at least in between each of them. And then about halfway through the whole process, I did a high level grit. I think it was 800 or 600 level sand. Once again, too much grit on true oil and you're just going to go right through the stuff because it's a very thin, natural feeling finish. But I'm going to go and steel wool the rest of this, and that is actually all I'm going to do for this finish. So, no matter how well we flatten our board and ensure everything is as straight as possible when making our neck, there is going to be a little discrepancy in the frets simply because of the machining process of the frets when they're made. They could have some variances if you press harder on some frets than others, etc. There's a number of problems that can cause uneven frets. One way to find if you have uneven frets is this thing called a fret rocker. And it's not necessary for the step, but it's helpful, as you can put it over 3 frets and check if there's any sort of rocking action. And just a few that I've checked so far on this guitar seem to be pretty. There's one. They seem to be pretty good, but it's not perfect. So I'm going to go ahead and do a fret level, and then all the stuff that needs to follow a fret level to get back your crowns and make the frets pretty and whatnot. As always, first thing when dealing with the neck, straight edge, make sure it's flat. Okay, now I've gone ahead and done a couple things while you guys weren't watching. As you can see, I've taped up the fingerboard to protect it from any tooling marks. We spent a long time getting that really nice, so there's no point in marring that surface now. And I've also drawn Sharpie across the top of all the frets. And this is going to help me keep track of my leveling process. As you can see, I've also taped off my humbuckers and anything that my leveling tools may hit. Just because I'm doing it at this stage doesn't mean you have to. You can do this before finishing work, before final sanding. It doesn't really matter. And in the case of doing it before finishing work and sanding, it does give you less of a risk of marring some of your work. But like I said, in this guitar's case, this is when I'm doing it. I don't always do it now, so you can pick and choose when you want to do it. This is not a required step, but it is something that I like to do. And I'll essentially go down the fretboard using this tool. You essentially want to choose the side that bridges 3 frets so that when you rock it, and this is a precision edge milled tool, so it can pick up very slight differences in height. Essentially, I'm going to take it, pick the side that will only do 3 frets, and then I'm essentially going to try and rock it. It's hard to hear, but you can hear a little tiny shift. So what I'm going to do is I'm going to put a little dot for a little tiny shift, and then if there's a lot, I will put a line. And although this isn't a 100% necessary step, because you do have the Sharpie on top of the frets to keep track of your leveling process, I do like to do this as an extra step just to let me know where I should focus, places to keep track of now that I know that there is an issue here, I'll come back to this one spot, especially after doing my leveling process, and it's just an added reassurance that I'm getting the work done. Also, I should probably mention that if you are going to do this step, levelness can change across the board, so I don't just check every fret. I'll check at the edge, the center, and the opposite edge. And there will sometimes be differences. As you can see, despite all the care that we took in making our board flat, there's a bunch of spots that have little tiny rocks and a couple that have significant rocks. I'll be keeping these in mind while doing the leveling. What we're going to be using for our fret leveling is a precision milled steel rod. I got mine from StewMac. Both sides are precision milled to be pretty much perfectly flat. And that's extremely important because of the requirements for strings. Stringed instruments, they require a very uniform flatness in the frets so that you don't have buzzing anywhere on your fretboard. I'm going to use 240 grit on one side, and sometimes I will use the 320 side as well, but usually the 240 gets everything I need done. And also keep in mind there's a reason why at this point I haven't folded the edges of the tape down. Tape will actually sometimes interact with the lacquer, and if you leave it on there for an hour or two plus, it may start to lift the lacquer. The solvents of the tape may react with it and cause finish problems. So I only fold those down at the very end when I need them out of the way. For this process, I don't. And essentially all I'm going to do is I'm going to be placing the bar down and running it, making sure I keep it flat. And you can see that the Sharpie is starting to be removed in some places, and while in others it's not. Some people say that you have to go one direction only. Some people say that you can put it on and move back and forth. I use a little bit of both. I don't feel that one way or the other is better or worse. Some people say that if you do the dual direction method that you'll bias a sanding to the center, and so you will have a slightly concave board. I haven't found that to be the case, but with my methods it requires so little fret leveling that I'm usually not leveling for that long or taking off any significant amount. That said, if you may want to stick to the one direction method. Also, when using a rod like this, it's quite heavy, so you don't actually need to put any pressure. The weight of the rod actually does the work. I'm just literally sliding it along the surface. The longer the rod, the better, obviously, because it's going to ensure flatness. StewMac and other Luthiery supply companies also sell shorter ones that are a lot cheaper than this, and so a lot of people tend towards those. They work, but they just require, in my experience, those require a lot more patience and sometimes experience to use, because it is a lot easier to put a dip in one section with the smaller one than it is this one, because this is bridging such a long area. I'm going to keep going. We'll come back when everything's level. Okay, I've essentially finished up most of the leveling, and this is where having a fret rocker, despite it not being a necessity, is nice, because I can go back and check those points that were originally off. And I found that I need a little more work on the E side, and there's a little tiny bit of Sharpie left on this fret where one of the issues is that I can still see. However, it's not as good a telltale sign as the fret rocker. That said, the Sharpie would have told you that as well. It's just nice to have a way to double check and to feel it as well as see it. I'm going to go back and fix this one area by just going up the E side, obviously like before, just following essentially the path the strings would take, because our fretboard is tapered and we want it flat along the string path. Okay, and this is what our fretboard looks like now. As you can see, there may be some Sharpie left on the sides, and some places I've taken off more than others, but they all now have a distinct silver spot at the top. And that means that we are now leveled. One thing that not everybody does, but I like to do, is called fall away. It's essentially taking off more of the fret past where it meets the body, because essentially your truss rod will act on the neck between where the neck meets the body and the nut only. So you won't be putting any bow in the truss rod for this area. So some people like to put a little fall away, some people find it unnecessary. You can choose to or not, and you can always come back and put fall away if you find that you're hitting any buzzing problems in this area. But I like to do it just as a precaution and simply because I like it. So we're going to show you how to do that next. What we're going to do is we're going to put two or three levels of blue tape, 1, 2 frets out from where your neck meets the body, and we're going to level from there, and I'll show you how to do that. Okay, so now I have my 2 layers of tape, 2 frets out from where the neck meets the body, and essentially what that's going to do is it's going to raise so that it puts a differential amount of pressure down here. So you're not sanding anything up the neck, but you are sanding the frets down the neck. And we're going to do it just like we did the other process. And this is just going to take a little bit. You really don't have to put much into it. And that should be enough. We now have these flat surfaces, and that will mess with the intonation of each fret, because we want the string contacting at a single point on the fret, not over a distance. So what we're going to have to do is recrown the frets, essentially make them rounded again, so that when you press, it just contacts, the string contacts the fret at one spot. This is a recrowning file. They come in a lot of different varieties, sizes for different fret wires, and grits. This happens to be the diamond one from StewMac. It's 150 grit and 300 grit. I happen to not have needed the 150 grit yet, so I would recommend, unless you plan on doing a lot of fret leveling, which you shouldn't have to, I suggest using the 300. And essentially all we're going to do is pass it over the fret, and you'd have to go pretty intensely to mess up the level that you just did. We're essentially trying to get rid of the Sharpie marker again that I put back on each of the frets, so that will tell us that we have a rounded surface again. As you can see, I folded down the edges of the tape because I am going to have to get in and do some of these up, and the tape would get in the way. So that essentially just means that from now forward, take about an hour to 2 hours. You shouldn't need that much time, but that's just to say, don't leave this with the tape on it and come back a couple hours later or tomorrow to finish up your work. You need to do it now. And I'm just going to do a couple of these so you can watch and get the feel for how fast and what all you need to do. And there you go. That's all it took. And I have one more thing I'm going to do with this file. I'm just going to break these corners a tiny bit, just to round them over a bit. We'll finish that round over in a little while. Okay, I've now gone through and recrowned all my frets, so there is no Sharpie on the top. As you can see, on some of them there may be some Sharpie still on the sides and whatnot. That's fine. What you're doing is removing the Sharpie from the top. And this is one thing that actually kind of irked me when I first was learning this process, because I thought, if I'm recrowning the fret, how could there be Sharpie left on the side? And also another thing that bugged me is it seemed like just 1 or 2 swipes, and if my leveling was good, now I know, then the Sharpie would all be gone. I thought there's no way it's possibly doing it this quickly, or it's recrowning and leaving stuff on the side. That's not the case. And one of the things that has to do with this is, if they made a file for every single different type of fret wire, you would have to buy tons of files just to get anything done, especially as a repair person. As a builder, you could theoretically just pick one wire and build with only that. Not that that's the best option, but you could. So what they've done is they've essentially made a file that crowns it, but might not necessarily bring all different fret wire in its range of use back to a perfect circle, and that would explain why it's leaving a little Sharpie on the sides and why it goes fast. Because yes, it is crowning. No, it may not bring it back to a perfect semicircle. And if you really want to ease your mind on that, go ahead and install a piece of fret wire into a scrap. Really grind it down, like take off several thousandths, and then try recrowning it with the Sharpie method. And you'll see that, yes, on stuff that is very ground, it will take more than just a couple swipes, and you will see the line go from a thick Sharpie down the center to something thinner, 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 and finally it'll disappear. As you can see, there's a tiny little piece of that line right in there left. And if you test on a more drastic subject, you'll be able to see that better, and at least with me, that gained me some confidence in my fretwork. It may work for you, or maybe you're already comfortable with it, but fretwork does take some time. Alright, last step in the actual grinding and whatnot shaping of frets is to take a file with a ground edge so that it's not going to mar your surface. It's basically any file. At home I use a triangle file. I borrowed this from a friend of mine for this video because it's a nice StewMac product, but a triangle file works as well. I don't have this at home. So essentially one non-abrasive edge and then two abrasive edges, and essentially all you're going to go around and do is just cut these little corners. Just go 1, 2, and do the other side 1, 2. That's it, and you can feel that any burring and whatnot is gone. The next step in fretwork, in my opinion, is especially grueling and time-consuming and just not fun. And as you guessed it, it's sanding. What we're essentially going to do is we're going to have to bring these frets back up to a nice polish, because the 240 that we used on the beam and then the 300 grit that we used to recrown have put lots of scratches in our fret wire. So what we're going to do is we're going to take 400, 800, and 1200 sandpaper and literally go through each of these frets and sand them up. We're not the top too much, and you don't have to do that much work, but it does need to get done. And we're going to go through and do that for both sides of every single fret with 400, 800, 1200, and then we're going to rub them out with steel wool. Alright, after you've gone through all the grits that I mentioned and Quado steel wool, it's now time to buff the frets out. They're a nice satin now, and actually some people like the satin look, especially if you don't have a shiny board. If you got a matte board. If you want to polish, I use a Dremel with a little polishing pad. Also, set it up on your buffer or on a grinder, set up a small buffing wheel. The problem with using your normal buffer, like we use with the finish on frets, is that metal, when polished, makes the buffing wheel go black, and then it won't do finish because it will mess with your finishing. So I like to keep the two separate. That's why I use the Dremel. And there you go. After all the frets have been buffed out nicely, I like to take some naphtha and clean them off, because like I said, polishing frets makes this black substance. And I like to get that off the frets before I remove the tape. Once you're done, go ahead and remove it. They're done.